Very good afternoon to all participants. Am I audible?
Yes, sir, you are audible.
Okay. I welcome all the participants for the last day sessions of our Atal FDP under the title of Industry 4.0 in Energy Sustainability and Climate Change. So today we have uh, last three sessions. So successfully from last 5 days, we have completed almost 10 sessions on the topic of energy sustainability and climate change. So today we have the topics on carbon capture and the mitigation of the pollution through industry. The expert is Dr. Praveen TR with us. So after that, we have 3:30 to 5:30 on the topic of human comfort and the climate change by expert Dr. Tabish Wahidi. Next, the session will be followed by Dr. Rahul Bhavne with the topic of current scenario of climate change. So once we complete the three sessions, we'll have the online test as well as the feedback. So we'll give the 1 hour time for the feedback. So we'll open the test timing for 1 hour so that all the participants can give their test as well as the feedback from the Atal portal itself. You have all the participants should give the feedback from Atal portal. So after that, we have the valedictory session. Okay. So this is the today's agenda of our Atal FTP session. So now, Dr. Praveen. Hello.
Is that I'm audible?
Uh, yes, sir. Yes, sir.
Okay,
So
that's
before moving forward, so just I will take 5 minutes to uh, give the brief introduction about today's speaker, Dr. Praveen TR. So Dr. Praveen TR currently he is a consultant founder at Harvest Desk, Bangalore. Uh, Dr. Praveen he secured his postdoctorate in the Department of Material Science from UNESP Sao Paulo, Brazil, and he earned his PhD in the mechanical engineering in the field of design and manufacturing from NITK Surathkal, India. He completed his ME in mechanical from UVC Bangalore and BE in the mechanical engineering from Tumkur. Dr. Praveen is having the professional experience. He worked as a faculty member at the different institutes. Also, he is an industrial consultant for Harvester Desk, which is founded by him only. And he's also consultant for the Rishita Engineers, Bangalore, from 2021. He's a consultant and guest faculty in the Department of Aeronautical Engineering in Jawaharlal College of Engineering and Technology at Kerala. Uh, also, he is giving the consultancy to various institutes, including private, state government, and government institutes. So, he was the production engineer in a Durga industry from 2006. He also worked as a research assistant. So, his area of interest are lightweight advanced material, strengthening, and the fatigue life increment technique, and also biodegradable materials, autonomous, uh, even automations, logic designs, and the optimization. Sir is having the skill set in FE software, SPD techniques, surface modification techniques, and X-ray diffraction. So he has the different awards, best paper award at a different international and national conferences. He is having the two patents which are granted on his name. Sir is having more than 10 international journal papers at a various publisher and also the international conferences. He has conducted workshops at a different level. Also, he has attended the workshop in a different institutes like IIT Madras. He conducted at NIT Surathkal also. So he's having the various. He's having the most of the knowledge in the all the engineering field. So I request Dr. Praveen sir to this session. Sir, you have time 2 to 3:30, sir. So forum is open for you, sir.
Thank you. Thank you very much. I will introduce. So I think I can now. People can see me for a short while. I will going to block my camera because I want these sessions to be go smoothly with data properly. If I use my camera for a long time, maybe data will be get affected. That's the reason I will turn off the camera.
Sure, sir. No problem.
Is that my screen is visible? My screen is visible?
Yes, sir, visible.
Oh, okay, that's fine. Nice. Okay, so I feel this is one of the good opportunity for me to interact with you guys. See, I always prefer these sessions to be interactive. Okay, I don't see it's not like mandatory. So I want you people to interact with me in the during the whole session. So don't wait any questions or any clarification or something you want to tell me or something you want to correct me. Also, it's welcome. Okay, so we will talk in the middle. We will exchange our thoughts. Okay, we will take it on towards in better way. So this is my presentation skill basically. So I want to interact more and more with the audience. So my topic is basically on carbon capture and mitigation of pollution through industry. See, I'm a mechanical engineer. I worked in different aspects of industries like aerospace industry, biomedical industry, manufacturing industry. I have worked in different aspects of science, and I'm passionate about physics. I don't consider as a mechanical engineering or a electrical engineering. So I always take any problem. It's a physics problem, science problem. So this is how we used to approach in our industry. So let me start with small concepts and how we can proceed. So here in this presentation, I will not go in detail of a research purpose. Okay, just because it's as I discussed with the coordinators, so it's a combination of all different people from different industries, right? So instead of going to in deep data points about the research and all, I will try to touch up the how we are living right now. So I will discuss some of our past, currently what we are doing and what we are going to expect, or maybe what is our future with respect to present situation. This is what I'm trying to cover in this presentation. So manufacturing industry. So why manufacturing industry? The question number one. Okay, why we need manufacturing industry? See, as we are we are already boarded ourselves, like we are the intelligent animals in the world, right? So like why we are intelligent means we can transfer our wealth to the next generations, right? So no any other living beings will do that one, like any animals. So they will eat for a one time, they will go, they will have to hunt for some next time and all. But we can store the food, we can build our house. Okay, we can process very good things, like we can properly lead our life with good skills, good environment and all. So how we are approaching, what we are approaching basically. See, because of this industrialization, so what we used to do, we are transferring material from one state to another state, that state which should support our life. Okay, we will be looking for the betterment of the human life. We will tell we are going to save the earth. It's actually not we are saving the earth, we are saving our human environment basically. So manufacturing industry, what does means it will take some raw material. In any manufacturing industry, they will process. Okay, they will process the raw material with the different processing parameters, processing technology. Okay, so based on that one, they will give the processed goods. Okay, if you take any, for example, food industry, if they want to manufacture a biscuit. Okay, they will buy the grains. Okay, what are the ingredients required as a raw material, like grains, some oils, some minerals like a salt, sugar, something like that. Okay, they will do the processing like grinding, dividing, powdering, the mixing, baking, adding the suitable flavors and all. Then finally they will prepare a processed good and they will try to bring into the market. The market is again a population. Okay, they will bring to the population. Okay, they will make little bit more comfortable about the for the population, so that we will be get attracted to the processed goods. So this is what manufacturing industries do. So basically, so just I will try to give just an process flow in automotive industry. How exactly? So this will be very similar to any other industries, but I'm taking automotive industry because it's very familiar to the everyone. Okay. So what were the main input here? So the main input in this industry is material, right? So what are the different type of materials? Okay, what the output we required? We choose the material based on the what are the output we. So we require energy. So this is very, very important in manufacturing sector. We need energy. We need raw material, whatever based on the output required. But energy is required in every manufacturing industry. So basically, we will use two types of energy. One is thermal energy. Another one is mechanical energy in terms of force or in terms of heat. Okay. Sometimes we will combine both together. Okay. We will use both force and heat together. For example, autoclave. Okay, in the autoclave we will use pressurize and temperature. Okay, for baking we will use temperature. Okay, for bending and metal operations we will use a force. Okay, like that, and we will use some water and some other. This is also one of the raw material. So how it process? For example, I want final good. Okay, if I want final goods, how it is going to start? Okay, so from the raw materials, I'm going to prepare my outline sheets. Okay, fabrication of sheets will be done. Okay, from these sheets I'm going to extract the what are the material property, what is the cost for this one. Okay, so everything I have to analyze. Automotive industry, then automotive component design, I have to design the component, manufacture, whether it's going to sustain the design or manufacturing are required. For example, if I want, if I come up with some geometry which is not able to manufacture, okay, so then my design is failed, right? So I have to think everything. Okay, so then we are going to assemble it by joining technologies, different thing. So assemble. So we will improve the quality of vehicle by doing NVH design, vibration or harness or noise harness. We are going to do. So we will now people are so not looking only for the automotive in terms of transport. We are looking for the safety also, right? As we are increasing from means. It's like that. Today is better than yesterday. So today we have a automotive car, like, okay, we have ambassador car, but we have today some other car. Okay, so what is the difference between previous car and today's car? They have a lot of improvement, right? Means today's knowledge is better than yesterday's knowledge. Okay, so today we have better product compared to yesterday product, means we have better knowledge than yesterday. So that is one crash safety device. We are going to we are implementing a lot of things. Durability is one of the important criteria because it will shows your endurance of the vehicle, right? Your endurance of the vehicle, maintenance. Okay, so how it is going to degrade, how to prevent this one. Okay, so dismantling, sorting. Okay, so after once it is used, okay, what is the end of our automotive goods? Okay, so how it is going to dismantle, what is the sorting, what is the recycle things. Okay, from the output again we are going to recycle, extract the solids, and we are going to recycle this one. So this is how just a manufacturing industry, how it works, how we plan a product like that. So this is what generally. But in this manufacturing industry, I concentrate in present session the energy. Okay, energy is my main focus because I'm going to talk about the pollutions and carbon capturing. So whatever the manufacturing industry we plan, so we need energy. So that is what we are going to talk right now. So when it comes, for example, another example is in construction industry. In construction industry, we need aggregates, we need red bricks, we need sand, we need cement. Wherever you considered here, okay, whatever you considered here, okay. So these raw materials are prepared by using energy, right? Aggregate, maybe right now we are using modern machineries which is run by electricity or fossil fuels. Okay, we have to crush the stone to get the aggregates. So again, here we are using energy in terms of mechanical energy from the electricity or fossil fuels. So sand, again we need to transport this sand from one place to another place. So we need energy here. Cement is one of the biggest energy consumption sector. Okay, so this is the one of the cement processing plant, how it is going to run. But because why I'm showing is because this is the one of the biggest energy consumption sector. So again, if you want to if I want to manufacture bricks, again I need to bring lot of raw materials. Then I have to cook it, right? I have to cook the bricks to make it stronger. Okay, or we have maybe in terms of engineering terms, we have to do for autoclave. Okay, so this is what civil industry requires, normal civil industry. So in comes to the preparation of cement. So we need a raw material coming from the truck. Okay, we are going to process it through crusher, secondary crusher. Then we are going to proportion. We are going to add the different parts of this one. Okay, grinding and milling, we are going to reduce the size of this one. Then we are going to put it in the hopper. Okay, preheater, clean. We are going to autoclave here again. Okay, lot of process in civil industry. This all process are consuming lot of energy. So here we are going to consume in terms of heat, in terms of mechanical forces. Okay, so energy consumption is very much in every manufacturing industries. So some of the example manufacturing industries, automotive industry, as I discussed, aerospace industry, okay, chemical industry, electronics industry, food and beverage, industrial machineries, textile and apparel, pharmaceuticals, plastic and rubber, paper and printing, metals and manufacturing, furnitures, consumer goods, building materials and constructions, energy, medical devices. So these are just a sample, okay, what we can list, but there is a unlisted lot of industrial areas are existing right now. So this I am just for the distribution of how energy. I'm just showing this thermograph. So this is an A400M aircraft which is trying to fly. So which is emitting lot of heat radiations, right? Which is emitting lot of heat radiation. This heat radiation is again coming from the combustion of the fuels based on the fossil fuels. Means every industry we need some energy, some sort of energy. So this sort of energy where we are getting. So that is very important in our discussions. Is it audible, clear? Am I audible?
Yes, sir.
Okay, that's good. So
Yes,
you people
Praveen.
can stop me in the middle. You can ask questions, or if you want to tell something, you can. It's always welcome. So now, just in the previous slides, I have tried to introduce about the industries, right? Manufacturing industries. In the next slide, we will take very important challenge for human life. Okay, it is very important challenge for human industrial pollutions. So as I told, we need energy. Okay, we need energy for the manufacturing or processing. So we need energy. Where we are going to get the energy? So energy is getting from lot of sources. So that I'm going to discuss in the upcoming slides. So what are the different pollutions? Right now we are concentrated about air pollution, which is very critical, very critical right now. You can see a lot of people suffering from the respiration problem. If you go to the North India, because of the temperature is dropping, the pollutions will be increased. Okay, at the same time, people will try to fire their agricultural land, which will emit lot of smogs. Okay, so it will increase the particulate matters in the air. Okay, which will make lot of difficulty in the respiration problem. The lakhs of people will die because of this air pollution. So second one is thermal pollution. Thermal pollution, what happens if you go to the nuclear power plant or steam power plant? So they will boil the water. Okay, they will make to produce the steam. So once they produce the steam, once they will feed to the turbine to convert heat energy into mechanical energy. Once it is done, they will take out the water. Okay, some part of the heat from the existing exhaust water, they will reuse it. Some other part of water will with the temperature, it will go to the environment. So what happens when you spread hot water with environment? Okay, that is also very important, critical. So water pollution, we will use lot of water in the industries, and we will the output of this the used water will be thrown again to some of the environment sources. Okay, like a river, some ponds. Okay, some of the tanks, or it is exposed to the atmosphere. Okay, so when you expose to the atmosphere, what happens? Because of the pressure difference, it will convert into the vapors and it will disperse in the local environment. Okay, So this is the water pollution, noise pollution. So noise pollution, it's not related to any of the direct pollutions, but it's like it's like a mental torture, okay, to the people. Okay, means you cannot live peacefully. That is what happens. You cannot build a house next to the railway tracks, right? Or you cannot build house next to the some of the big industries, okay, because of the noise pollution. Means it will degrade the human quality of life, okay. So that is what happens. So thermal pollution I explained, water pollution just explained, but we are more looking concentrate towards the air pollution in these sessions. So as I discussed, what is pollution? So pollution basically any substance, okay, it may be solid, liquid, or a gas, or a form of energy such as heat, sound, or radioactivity, okay, into the environment at the rate that exceeds the rate at which it can be dispersed, diluted, decomposed, recycled, or stored in some harmless form, okay. So this is what happens. We know that everywhere we have a threshold, right? Okay. So how much water I can drink in a day? I can drink water almost 2 to 3 liters, maximum 3.5 liters of the water in a day. Okay. If I drink water 10 liters per day, what's going to happen? Okay. So means everywhere we have a threshold limit. So if I drink more than the recommended water, my body will start degrading, okay, or started troubling, okay, because my kidney is like a membrane, right? So the function of kidney or efficiency of the kidney will get reduced because of the lot of fluid inside, because it has to work a lot, it has to filter a lot, it has to do a lot of work, right? Means its efficiency, its fatigue life, okay, everything will be get affected. Hence, everywhere we have a threshold limits. Similarly, in the atmosphere, whatever we have, air, water, food, what are the things we know, okay, so everything will be have a limits, okay. Once it is crossed their limits or it is decreased to their limit, so we will consider that environment as not safety or not good for living, okay. So this is how we are going to define air pollution. So when it comes to air pollution, okay, air pollution is the contamination of air caused by the presence of chemicals in the atmosphere that is hazardous to the human and other living beings, health, or cause damages to the climate materials. Its living being health cause damage to the climate materials. So what happens? Air is very primary criteria for living, right? So we cannot stop breathing. Okay, we cannot stop breathing. That is basically because the oxygen is very important for our brain. Okay, so brain will stop functioning when it will lose their food. What is the food for brain? It's a oxygen. So how it's going to work? Just it's like whatever we eat. Okay, so it's like it will generate the heat. Okay, it will make body to comfortable into the proper working condition. So it will make your lungs to receive oxygen from the atmosphere. Okay, when the lungs receive the oxygen from the atmosphere, so it will take into the blood streams. Okay, so heart will make mixture of lungs will make try to solve the oxygen into the blood, then it will blood the oxygen rich pump blood will be pumped to the brain. Okay, it will receive the food and it will be active. So this is how. So hence air is very important criteria for surviving any living being. Okay, so air pollutants include gases such as ammonia, carbon monoxide, sulfur dioxide, nitrous oxide, methane, carbon dioxide, and chlorofluorocarbons. Okay, so these are all actually we know in our past studies and all. Okay, some of the particles, both inorganic and organic and living molecules. Okay, air pollution may cause illness, allergies, and even death in the people. Okay, so it is very common right now because of the particulate matters. Okay, it can also harm other living species such as animals and food crops. Okay, and it can impact the natural environment such as a climate change, ozone depletion, or habitat degradation. Okay, or the built environment, for example, acid rain. Okay, so we have to think exactly what's happening in our surroundings. Okay, so what's happening in our surroundings? So everything is changes with the time, right? So it's how we are going to define a life. Life is a change of state. Every time, every second, we are going to change. Okay, our surroundings will be changing, we self will be changed, everything will change because of the energy we are receiving from some or some other sources, like it may be renewable energy sources like a sun or something like fossil fuels and all. So every time we are going to change in phase. Okay, so as the change of phase is occurring in our surroundings, the surroundings may degrade or engrade. Okay, degrade or engrade. So right now, as we are moving more and more towards the sophisticated lifestyle, okay, we using a lot of uh, what we can tell, transportation systems to travel from one place to another place. Okay, we have very good housing. Okay, to protect from the natural environment effects and all. So like this, we are going to engrade and degrade. So when you change from one phase to another phase, there will be some degradation, some there will be some ingradation. This is what happens with the processing. Okay, when you process something, something will be lost, something will be gained. That is what happens. So air pollution may be caused by both human activities and natural phenomena. So this is very important. So even though there is no human activities, okay, there is no human activities, there is a air pollution by natural phenomena. Okay, air pollution is a major risk factor for variety of pollution related to disorders such as respiratory infections, heart disease, COPD, stroke, and lung cancers. So these are all because, see, some of our internal organs get affected because of the air quality. Okay, so this is very, very important. We have to understand to survive more and better life. Okay, so air pollution is majorly risk because it will cause respiratory infections, heart disease, COPD, stroke, and lung cancers. Okay, so growing research show that exposure to the air pollution in linked to lower IQ scores. Okay, people IQs also decreasing because they cannot think properly. Because when the person is got sick, okay, he will be thinking to get out of sick, right? He cannot think other than that in better way. This is what happens. And obviously, when you got deficiency in the food or deficiency in the air, what is the intake deficiency? It will be show the deficiency in your thinking pattern also. That is what happens with the lower IQ scores. Okay, decreased cognition, okay, and increased risk of psychiatric illness such as depressions, poor parental health, poor air quality has far-reaching consequences of human health, although mostly affects the respiratory and cardiovascular systems. So this is very, very important. So that is the reason people has to get some clean source of air. Okay, every time. Okay, so this is very, very important. It is related, lot of things related to the air actually. So here, as it is, as I am mentioning, okay, there are a lot of psychiatric illness. What is psychiatric illness? Psychiatric illness, basically, it's our behavior, right? I may get angry, okay, I may get depressed, okay, I may get loss of energy, I feel like that, okay, I will be losing interest in lot of things. Okay, these are all psychiatric illness. See, the pollution is related to our healthy life, okay, happy life. Okay, psychiatric illness is very, very important. If you cannot think properly, we cannot be happy. Okay, so hence the pollution control is very, very important. So any doubts till now? Okay. So let's speak some more interesting things about our environment, how we survive, how we think. Okay. So this is how metabolism occurs. Okay. So whatever we eat, okay. So basically heat is converted, food will be digested in our stomach. Okay. Once the stomach is digested, will be passed to the intestines. Okay. It will extract the nutrients and all. Okay. Then it will be pumped to the remaining part of the bodies and all. Okay. So basic criteria of the food is it has to generate heat. Okay. It has to generate heat to keep our body warm. Okay. Once the body is warm, so other part of the bodies will be start working properly, means it will be working already properly, means it will be more comfortable. So once it is more comfortable, okay, so it will be, everything will be work properly. So basically our brain is very, very important for everything, which controls everything. Okay, so that is the basic control system. Okay, this is how our industry also evolved. Okay, based on the brain working methodology, we work with automations, we work with AI technology, neural networks, everything we are simulating from the nature basically. So what is happening? So brain will send proper signal to the heart, so proper signal to the lungs, signal to the stomach, signal to every part of the body. So how exactly brain works? Brain will get supply oxygen. Okay, so you breathe oxygen here. Okay, when you breathe oxygen, good oxygen, you will be you will be having a very good oxygen rich blood. Okay, so this is the pump. Okay, so this blood is coming from heart to the lungs. Okay, from the lungs it will go to the brain again. Okay, so when you have a very good oxygen, okay, you will be having a better thinking patterns. Okay, so you will be having a better thinking patterns. So that is the reason. So we need better air surround us. So these are some other pollutions by like water and all. What's going to happen? So when some heavy metals is involved in your water, some other food, what is going to happen? So we will be having it's affected your headache and brain again, headache and fatigue. Okay, respiratory illness, cardiovascular illness, liver damage, gastritis, skin irritations, kidney damage. Lot of things will be there. Okay, means it will affect lot of our proper lifestyle. So here I am trying to present a chart here. Okay, this is basal metabolic rates. Okay, means this is during the metabolic process. Okay, so how much energy is required? Okay, how much energy is required and what are the oxygen level is required? Okay, liver. Okay, 23 watts of energy is required with 60 ml milliliters of oxygen per minute. Okay, so brain we need 47, skeletal muscle we need 45, kidney we need 26, heart we need 17 ml of oxygen per minute, others we need 48 ml of oxygen per minute. Means we need approximately 250 milliliter of oxygen per minute every minute. Okay, 250 milliliter. Okay, if you think this is at rest. Okay, so this is your at rest. When you walking, okay, obviously this will be spiked more and more. Okay, so hence what it shows, you need very good air surrounded by you. Okay, then only we can live comfortable life, right? So this is the basic energy equations for surviving. Okay, how we are going to survive? So as I told, we need a heat energy to keep our body warm. Okay, so this is the output we require. Okay, in terms of kilojoules. Okay, so this we will be used in terms of heat, move, think, grow, whatever the activities we do, sweat, everything. So it is from this energy. Okay, so how we are going to get? So this is the basically hydrocarbons. Okay, it may be fat, some may be sugar, glucose, whatever it may be. Okay, so this is the base product. It is going to combine with oxygen. Okay, when it combine with oxygen, it is going to give a byproduct of carbon dioxide. Okay, and water. Okay, with energy output. Means basically we are using oxygen. Okay, so we are using oxygen. Our output will be a carbon dioxide, water, and energy. Okay, so oxygen is very, very important. Okay, oxygen is very important and food also very important. So this is what we eat or what we consume. Okay, so what happens if basic energy equation get altered? Okay, so just you think if your whatever food it is malt. Okay, means it is altered. Okay, something which is not required for you, it is added to your energy system. Sorry, your equation. Okay, energy equation. So here something is bad, your reactions out byproducts will be something bad. Means it is not expected from your body, right? It is not expected from your body. Then only your basic function of organs will be get affected. Okay, if you eat something bad, basically once your stomach get upset. Okay, you may get headache, or you maybe get your if you eat something more cholesterol, your blockages will be there. Okay, lot of things. Basically whatever we eat, okay, so that is what we reflect in our health system. So this is what happens. So hence a proper food, a proper oxygen is very, very important in our life. So this is the basic what I discussed till now, how we are going to survive in the present scenario with the our human environment. Okay, how our human environment is created. Okay, the next question is how is our human environment is created and how it is maintained. Okay, so basically this is our solar system, this is our sun. Okay, our earth and moon. Okay, so it will be rotating in inclined position. Okay, it will be rotating at inclined rotation and it's spinning its own axis, right? So there is a two angular movements will be there. Okay, so when it is there, you can see, okay, as it is spinning. Okay, so the area exposed to the sun, okay, the area exposed to the sun is keep on changing with the spinning axis. Okay, so that is what our daylight and night. Okay, day and night. Okay, so when it is exposed to the sun, okay, we will be having a day time, when it is back to the moon, sorry, back to the sun, it will be having a night, okay, night mode, okay. So what happens when it is exposed to the sun? Okay, a 43% of the total radiant energy emitted from the sun is in the visible part. Okay, so for example, we are using 100% of solar, some of the energy, okay, out of the sun, okay, some energy we are going to receive in terms of electromagnetic radiations. Okay, so this is the wave we are going to receive in form of energy. Okay, so we will be receiving X-rays, UV rays, okay, visible rays, okay, infrared rays, microwaves, okay, radio waves, and some other small other profiles of wave natures. Okay, so this is what we are going to receive from the earth. So this radiation will be traveling from miles, light years. Okay, so this is traveling from the very long distance. Okay, it is not affected so much with the surrounding environment because it's considered as a vacuum. Okay, so once the energy is whatever the energy we are receiving from the earth, so in that 43% of the total radiant energy is emitted from the sun is a visible part of the spectrum. Okay, so this is the visible part. Okay, this is the visible light what we are going to receive the sun energy. Okay, the bulk of the remainder lies in the near infrared. Okay, near infrared, this is what infrared, 43%, 49%. Okay, so we have to consume, so we will be receiving energy in terms of a light energy and heat energy. Okay, so basically what type of energies we are going to receive? Light energy and heat energy we are going to receive. Okay, and the ultraviolet section, 7%, less than 1% solar radiations emitted by X-ray, gamma waves, and radio waves. Means we have little bit ultra UV waves. Okay, so this UV is the reason for why we are going to get sunburn. Okay, so it is very strong. Okay, because of the short wavelength. Okay, so when the wavelength is longer, the behavior is different. When the wavelength is shorter, the behavior is different. So in the short wavelength, it can easily penetrate inside our body. Okay, it is easily penetrate inside our body. That's the reason we are using X-rays. Okay, I think every people we know the X-rays, right? Means when we go to the orthopedic doctors, they will go for X-rays. Means it can penetrate our body, our bone, and it will create an image. Okay, that they can study. Means so the shorter wavelength means the penetration, more penetration energy. Okay, so basically what we have understood is the major source of energy from the sun in terms of a visible light and heat energy. Okay, so this is what we are able to get from the sun. So energy budget. Okay, Earth's energy budget. See, for example, we have, just imagine you have some bowl in your home. Okay, so you are putting every day 1 liter of the milk. Okay, and you will be taking out every day 1 liter of the milk. Okay, so that your your balance of the milk, the day's milk will be 0. Okay, if you buy 2 liters of milk, if you consume 1 liter of the milk, the 1 liter of the milk will get wasted, right? It is not balanced. Okay, so you are going to accumulate with a lot of waste things. So similarly, what happens with our environment also? So Earth balance means, for example, incoming solar energy. For example, if you consider 100% of solar energy, whatever we are receiving here, okay, out of that, 51% will be received by land and oceans. Okay, so whatever the land we are going to receive, and the ocean will be, the Earth's surface will be 51% will be reduced. Okay, so this actually will create a lot of biological active systems. Okay, so this makes Earth surface warmer. Okay, that's the way we are able to live in the Earth surface. Okay, so this 51% is very, very crucial and important. Okay, so out of that, 7% will be conduction and rising air. Okay, 3% will be in the clouds rising. Okay, so 16% will be in the atmosphere, absorbed by atmosphere. Okay, so this is what happens when it comes to this one. If you match exactly what happens, okay, 64% will be emitted in this way. Okay, that is will be in terms of air rising. Okay, clouds rising, atmosphere, and radiate to the escape to the clouds. Okay, it will go back to the system. Okay, remaining 6%, how it's going to radiate directly to the space from the Earth. Okay, it will directly radiate from the space. Radiation absorbed by the atmosphere is 15%. Okay, carried to the clouds and the atmosphere by latent heat, water vapors by 23%. This is how the cycle happens. We will receive the energy in terms of light and heat. Okay, the Earth's surface will be get warm. So when it is warm, we will be the water on the surface will be get moisture, okay, it will get vaporized, it will pump to create the clouds. Okay, when the clouds goes up or taller and taller, it will lose the temperature, which it will lose the heat, it will become condensed. Okay, when it is condensed, it will gain the weight. When the weight is more, it will come back again in terms of rain. Okay, but when it comes back into when it condenses, it will releases the heat energy. The energy will be go back to the space. So this is what exactly ideal cycle. Okay, so this is the ideal cycle. That is what we expect. But whether it happens, ideal cycles is only for theoretical purpose. This is not happens exactly. So what happens exactly? Come to this picture. Okay, so again we are receiving solar radiations 100% we are receiving. Okay, so out of 100%, 50% of direct and diffuse radiation absorbed by the land and sea. Okay, so 50% just it's very similar. So I have taken these two pictures from the different literatures. That's the reason 1% or some percent will be very dear, but it's very near variations. Okay, so here I'm considering 50% will be directed towards the land and sea. Okay, so this is the responsible for making warm. Okay, so once it is done, okay, 5% will be reflected from the land and sea directly to the space. Okay, 20% of radiation absorbed with atmosphere and clouds. Okay, whatever the remaining 50% out of the 20% will be in the clouds, absorbed and released by the clouds. It will go back. Okay, 20 to 20, there is no reduction. 5% back scattered to the space. Okay, so if you compare the energy here, okay, 20, 25, 500%. Okay, but it will not happen exactly because there is a growth of bio environment, like plants will grow, humans will get bigger, animals will get bigger. Okay, we are going to consume some part of the material, will receive the energy, will grow further and further, so it will not balance it exactly. Okay, so what happens in actual scenario? Any doubts? Okay, so actual scenario. So man-made forcings include particle pollutions, aerosols, which absorbs and reflect the incoming slides. Okay, means whatever we produce, manufacture and all energy sectors, no, there will be a lot of particle pollutions. Okay, that is what PM10, PM2, PM3, based on the particle size, we are going to distinguish the aerosols. Okay, which absorbs and reflect the incoming sunlight. Deforestation, which changes how the earth surface reflects and absorbs the sunlight, and rising the concentration of atmospheric carbon dioxide. Okay, so this is very, very important. I'm going to discuss a little bit more about the carbon dioxide, as our session is concentrated on carbon capturing. Okay, and other greenhouse gases, which decrease the heat radiated to the space, and forcing can trigger feedback loops that it can intensify or weaken the original event. Okay, so we spend some more time in this picture. Okay, so what happens exactly? So when you receive the energy from the sun, and our human activities will be there, so we will be doing a lot of interactions, right? So gas interruption, like a volcano, it's a natural phenomena. Okay, so when the fossil fuels is burned, okay, so there is a tree which will respiration, right? It will breathe. Okay, it will give CO2 and create photosynthesis also. Okay, so sorry, it will emit CO2 and O2, both trees, plantations. CO2 will be emitted during the daytime, and CO2 will be consumed during the daytime. When there is no photosynthesis, there is no consumptions of oxygen. Okay, so like that. So dissolution and all. So what happens basically, aerosols which will be there in the complete atmosphere. Okay, so the aerosols it will do, it will disturb the ray of energy. Okay, it will disturb. When it is disturbed, it will divert. The energy beam will be diverted and it will be diffracted. Okay, so when it is diffracted, it will receive the energy. Okay, in the middle of the middle path. Okay, it will not the temperature, the waves will be not reach the warm earth surface to make it warm, and the lot of disturbance will be there. Okay, so similarly people are doing deforestation, right? So when you deforestation, what happens? The photosynthesis will be get affected. Okay, when the photosynthesis will be get affected, the production of O2 and consumption of CO2 will be get affected. Okay, when the consumption of CO2 will be get affected, the presence of CO2 in the atmosphere will be more and more. Okay, so this is what happens. Similarly, in the seabed also, okay, the living, sorry, for example, marine life like a fish, some other water bodies, water animals will be emitting carbon dioxide, and this will be consumed by the marine plantations. Okay, so this is how actual synthesis works. So basically, we will be emitting more CO2 because of our human activities. Okay, so what exactly happened in the combustion? Okay, so in the combustion reaction, we need hydrocarbons, right? So this is what I told, like a sugar, fat, something like that. Okay, hydrocarbons we need. So this hydrocarbon, it always required oxygen, okay, to get our required heat. Okay, so oxygen is very must. Okay, so when you use the oxygen with hydrocarbons, so you the byproduct always you're going to get a carbon dioxide, okay, and water. So how much energy you want, in the similar way, the carbon dioxide will be increased. More energy, more carbon dioxide. Less energy, less carbon dioxide. It's a directly proportional, basically. So in this picture, I'm trying to show fossil fuel consumption in 2023. Okay, so there is a different fossil fuels like coal, natural gas, and oil. Okay, so we can see China will be how much it's consuming. Okay, it's consuming lot of energy, 140. Okay, 140, 174 million barrels of oil equivalent. Okay, 174 million barrels of oil it's consuming. Okay, next US, next is India, another one is the remaining part of. So why these countries are important? If you see in the China, the population is more. Okay, the manufacturing industries are more, but hence the consumption is more. Okay, if you come to the US also, they have also very good manufacturing industry. Even the population is less, they have a lot of manufacturing industry, hence consumption is more. So, and there is a one more thing is they're living in the cold countries, right? They need more energies to make it better life. Like they have to use heaters and some other additional sustainable machineries for the better environment. Okay, so India, we are dependent on coal. Okay, we are using oil. Gas is very small percentage. Okay, so still right now we're electrifying our Indian railway network and all, so that we can decrease the use of coal in terms of energy production. So in alternatively, we will be planning nuclear energies and all, but still there is a lot of requirement of fossil fuels right now. So after that, global energy demand projected. Okay, so how much energy projected? Okay, so right now I'm trying to see there is the energy product you can see till lot of years, but I am restricting to the 2050 because forecast I'm trying to forecast in the realistic scenario. Okay, in 1990s, 1980s. Okay, we will be having around 150 million barrels of oil equivalent in the world. Okay, it's a world chart. Okay, it's not a country wise, it's a world chart. So 150 million barrels of oil will be consuming. So right now, okay, we'll be consuming nearly more than 410 or 420 million barrels. Just to think how much energy, how much fuel you consume, you will use such oxygen, such a quantity of oxygen also is required for your energy generation. Okay, such a such quantity of oxygen also required for energy generation, and so much quantity of carbon dioxide is emitting. Okay, so hence energy production is completely directly proportional to the carbon dioxide emissions. Okay, so this is what happens right now. We are somewhere here. Okay, but we will be planning. It is planned, forecasted to we are going to increase the energy demand. So hence we have to think something to reduce the pollutions. Okay, so this is our energy in India. Okay, this is recently I took it. Okay, so in 2003 it was here. Okay, it was forecasted for 20. Okay, 30, 40. Okay, so this is what billion tons of oil equivalent. Okay, so it will be like for example, it will 0.075 billion tons of oil in the 13. Okay, it will increase to 1. Okay, so then after in the 2030 it's more than 1.4, something like that. Okay, so in 40 we'll be using 2. Okay, 2 billion tons of oil. Okay, so in that one, this is the coal part. Okay, so you can see the coal part is increasing here also. Okay, so this shows that we cannot avoid the fossil fuels. Okay, so again we have the oil parts also. Oil parts also increase because the demand is increased. We cannot stop using oil and coal. We have to use. Okay, So other than that, people are planning other forms of energy like bioenergy, natural gases, hydropower, nuclear, and other renewable energies. So this is what this is. You can see this is a very bigger man, okay, which is not used by the fossil fuels. Okay, so this is very advantageous. So this is how our energy demand we are planning for 2050. So next point is air quality index. Okay, so air quality index means it shows how good our air. Okay, is it good to breathe? It is bad to breathe. We survive? Cannot we survive? So this shows the index. Okay, so that is what air quality index. So I'm here in the first picture. I'm trying to show 10 top world's most polluted cities. Okay, average air quality in 2022. Okay, in the previous 2 years back. Okay, so you can see here Kashgar. Okay, it's from the China. Okay, so we are already crossed 200. It's like it will be around 222 something like that. So Delhi we have in our country, Ghaziabad. Okay, so this is some other city, Noida in India. Okay, Faridabad in India. Okay, Lahore from the Pakistan. Okay, Sahasra I don't know exactly. We have Patna also here. Okay, so we have to think India has to in the world most populated country, we are all listed like in New Delhi, Ghaziabad, Noida, okay, Faridabad, okay, we have Patna. A lot of Indian cities are listed here. So it is very important for us to think. Okay, when it comes to the polluted countries, okay, so Bangladesh, Kuwait, Chad, UAE, okay, India. So we are just in the border. Okay, so we are in the just in the border. Our air quality overall country quality index is less than 100. Okay, so this is not so bad but not so good also. Okay, so we have to think. So this is the pollution chart. Okay, when we are getting this kind of air quality, from where we are going to get this pollutants? Okay, so transportation industry will be contribute 14%, building 6%, okay, agriculture and forestry land 24%, okay, electricity heat production 25%, other, okay, industry 21%, others is 10%. So we have to cut out, we have to look it back into these industries. Okay, how can we do it better way? Okay, so this is what we required. So basic air quality index chart, okay, what I'm showing here. So green, yellow, orange, red, purple, and maroon. Okay, so you can see green 0 to 50. If the AQI is less than 50, the air quality is satisfactory and air pollution poses little or no risk. Okay, means this is the air you can breathe in good conditions. Okay, so if it is yellow or moderate, it's in between 51 to 100. Air quality is acceptable. However, there may be a risk for some people, particularly those who are usually sensitive to air pollutions. Okay, so it's okay. Okay, it's okay, but it's not so good. Okay, so orange, unhealthy and sensitive groups. Okay, members of sensitive groups may experience health effects. The general public less likely to be affected. So this is the main reason for people suffering from asthma, other respiratory problems and all. Okay, so we always have to think for the air quality index. Red, very unhealthy. Some members of the general public may experience health effects. Membranes, sensitive groups may experience the more serious health effects. Okay, so if you go here, okay, Delhi is classed at 200. Okay, Ghaziabad is classed at 200. Okay, Noida is classed at 200. Okay, so Patna is near to this one. Okay, Faridabad is classed at 200. Okay, means they are all in this red. Okay, they are already in the unhealthy conditions. Okay, so that is the reason people more repeatedly going to the hospital for the respiratory issues. Okay, so purple, very unhealthy. It's more than 201 to 300. Okay, health alert. The risk of health effects is increased for everyone. Okay, even though if healthy people and younger age, they will be having they will be get affected. Okay, maroon, there is no talk about this one. Okay, it's conditionally hazardous. Okay, so we cannot take any air, or we cannot breathe any situation in these conditions. Okay, so hence air quality is very important. So this shows air quality directly shows the life quality. Okay, we can convert in these terms. Okay, air quality basically comes into the life quality. So think, so that's the reason, at least go to some places where you will be having good air quality index, breathe for some time, get release of your stress and all, come back, work. So this is how lifestyle is required right now. Okay, main air pollution sources, as I discussed in the previous slide, just similar to that one, waste and treatment. Okay, when you do the waste treatment, lot of chemicals will be released like a methane. Okay, lot of other gases will be released into the environment. Okay, farming. Okay, when you burn the farming waste, okay, there is lot of smokes will be get reduced. Transports, again, it's a combustion process. You'll be getting lot of emissions. Okay, works and minings. Okay, basically, if you want to get something, you need to burn energy, right? When you're burning energy, you are going to get production. Okay, livestock. When we breathe, we receive oxygen. Okay, when and emit carbon dioxide, livestock. Okay, so water treatment, residential, industrial, volcanoes, combustion. So everything is very similar. Okay, so as it mentioned earlier, every process, natural process or man-made process, there will be air pollutions. Okay, but natural process is not so easy to control, but man-made process, at least we can try to control. That is what the main intention. So type of industrial emissions. Okay, industrial emissions come from a different source, have important consequences for health and environment, which underlines the importance of controlling the reducing industrial emissions. Okay, the main industrial emissions is carbon dioxide. Okay, main greenhouse gas emitted from fossil fuel combustion, means that is what we are discussing. How much energy is required? Such big amount of carbon dioxide will be emitted to the surroundings. Okay, so in power plants and manufacturing, contributes to global warming and climate change. Global warming. Okay, so global warming means the temperature of the globe is increasing. It's alarming already. Methane gas emitted during the production of production and transport of coal, oil, and natural gases, as well as by certain industrial process, is more potent than CO2 in terms of impact on global warming. Okay, methane is more potent. Okay, I will explain CO2 and CH4 why it is more potent in the upcoming slide. Okay, nitrogen oxides, gases resulting from high temperature reactions in industrial process and vehicle combustion. Okay, so they can cause respiratory problems and contribute to the formation of the smog and acid rains. Okay, so because air is a combination of nitrogen and oxygen. When you supply air for the combustion, you will be supplying nitrogen also. So when nitrogen is exposed to the high temperature with oxygen, there will be a production of nitrous oxides. Okay, that is called smog and acid rains. Okay, volatile organic compounds emitted from solvents, paints, industrial process. They are precursors of ground level ozones affecting air quality and respiratory health. Means, so basically it's like acetone, butanol. Okay, these kind of chemicals, it will evaporate so easily, combine with atmosphere, react with the oxygen, and it will create a ozone in the lower levels. That is not good actually. Okay, some other emissions are particulate matters. Okay, means it's a small particles. Okay, from combustion on stationary and mobile sources, they can penetrate deep in the lungs and cause cardiovascular and respiratory problems. Okay, so how much possible, that much of emission we have to reduce. Okay, hydrogen sulfide, rotten X odor gas released by a industrial process such as oil refining. Okay, at high concentration, it can be toxic and affect the human health. Okay, so one of the basic behavior of hydrogen sulfide is very bad smell. That is what a rotten egg odor smell. When the people will be having what gastritis, okay, so they will be start when they fart. Okay, it's a practical, right, science. Okay, when they fart, they will be having a very bad smell. That is the smell of hydrogen sulfide. Okay, that indicates that the sulfide content is more in the body and your digestion system will be having a problem. Okay, asbestos, mineral fibers used in the construction and manufacturing. Inhalation of asbestos fibers can cause serious lung diseases, including cancers. So in this category, it's very important. Recently, I came with one of the cases in the local. Okay, so people is working in the fiber industry. Okay, so some of the small fiber went inside their lungs. Okay, so in the starting, it doesn't create any problem. Okay, after long time, means after long years. Okay, so the patient is getting a cancer symptom. Okay, so he's undergone a cancer treatment right now. That is basically a mineral fiber which is went inside the lung. Okay, lead, heavy metal emitted by the metallurgical and battery industries. Lead expose can be adversely affect the nerve system, especially the children. So that is the one talk right now. One challenge we have to address right now. People are talking about the EV, right? Electric vehicles. So when the electric vehicle comes in the picture, we'll be working for the batteries. Okay, batteries is the one of the main component in the EVs. Okay, so this will be manufactured by lead. Okay, so how we are going to recycle this one? That is one of the biggest challenge. Okay, so mercury, liquid metal residue from the coal burning and chlorine production. This is highly toxic and can accumulate in the food chain, affecting human and animal health. Okay, so this is the just top industrial emissions. There is a lot of other emissions also. Okay. So just is it possible? Can we have a 1-minute discussion so that I can take in further way? So maybe I can correct. If you people have any questions or anything to talk right now, so any doubts?
Dear participants, if you have any question or we want to interact with our expert, so we are having the time for 1 or 2 minutes. After that, sir will continue the presentation. So in between, if you have any discussion with the sir. Okay, I think, sir, it will be we will take at the last.
Okay, fine, no problem. Okay, now with relative to this industrial emissions of air pollutants associated with the fossil fuel consumptions. So as I discussed, okay, fossil fuels is one of the primary source, as it's oil, coal, and natural gases, right? So this fuel fuels are chemical energy. Basically, we are going to convert in mechanical energy or heat energy by combustion. Okay, so what happens? Fossil fuels basically will be containing a combination of carbon, hydrogen, nitrogen, sulfur, and oxygen. Okay, so when you feed this one, okay, so combustion will take place. So this combustion, what are the outputs here? Carbon monoxide, carbon dioxide, sulfur, sulfur-based oxides, nitrogen-based oxides, nitric oxide. Okay, volatile organic components or hydrocarbons. Okay, so because of the improper combustion. Okay, so there is a particulate matters also. PM10, a coarse particle less than 10 microns. Okay, PM 2.2, 2.5 fine particle less than 2 microns. Okay, so this is a part of ammonia also emitted. Okay, so when you see this graph, okay, so what is the basic more emitted? Carbon dioxide, right? Because combustion means oxygen will be the inlet and input raw material, and carbon dioxide is the processed output. Okay, so how much oxygen is supplied, that much of combustion will happen, and similar way carbon dioxide is released. So in the air, so only 23% of oxygen is there, and 77% near to 75 to 77% will be the nitrogen will be there. So such a quantity of nitrogen supplied in the combustion means high temperature zone with oxygen rich, there will be a nitrous oxides will be there. Okay, there is a clear-cut possibility. So combustion happens not in ideal conditions. So this is in a realistic situation. So some part of the combustion is not completed. So there is a emission of carbon monoxides. Okay, sulfur dioxides again from the environment. So PM10, that is the particulate matters. Okay, volatile organic compounds. Okay, lead and other toxins. So these are the outputs we are getting from the fossil fuel consumption. So this indicates that, okay, this indicates what? This indicates so how much we burn the fossil fuel, okay, such a quantity of emissions we are going to get it. Okay, such a quantity of emissions we are going to get it. Okay, so now onwards, I will try to concentrate only on CO2 because CO2 is one of the major contribution for the global warming. Okay, we have to look for this one because the temperature of the earth is increasing, right? The temperature of the earth is increasing. We have to look for this one. Okay, so let's try to understand what exactly carbon dioxide and global warming is doing. Okay, so this is the recent data what I got it. Okay, from the internet sources. Okay, so you can see here the temperature scale. Okay, in degrees Celsius. this is the minus 0.5, okay, 0, 0.5 and 1. Okay, so this is a change in temperature. This is not like minus 0.5 temperature degree. Okay, just change in temperature. Okay, so if you take the x-axis, this is the timeline. Okay, 1880, 1900, 1920, 1940, 1960, 1980, 2000, 2020. Okay, so if you see 1880 to till 1940 or 1950, the change in temperature or increase in the temperature, okay, will be very less here. Okay, even though we will be coming back here. So if you see the increase in temperature from here to 2020, it's increasing linearly, right? So if you take a data back, industrial data back, the industry is not so powerful in this area, this time. Okay, means the use of fossil fuel is very less. Okay, people is used it only for cooking purpose or some other purpose. Okay, because automobile was invented in during this session, aerospace industry coming in during this session, manufacturing growth will happen in this during. So this is the reflected in this region. Okay, in this time people got knowledge. Okay, in this time people got implemented. Okay, when they implemented, they started burning more and more fossil fuels. Okay, as the result of fossil fuels, okay, there is a lot of greenhouse gases in the atmosphere, which will trap the temperature. Okay, which will trap the temperature, which actually increases the Earth's temperature. Okay, so what happens when the Earth temperature increases? Okay, so here I'm not mentioned anywhere here, but I want to make it one concept here. We have ices in the North Pole and South Pole, right? Okay, means it's a H2O in the form of solid, in the form of liquid, in the form of gas, vapors. Okay, so let me have this ice water discussion at the end. Okay, let me try to finish. So this what I'm intended. Maybe in the discussion part, I will try to explain exactly what happens with the water cycle. Okay. Global warming is the long-term heating of Earth's surface, observed since in the pre-industrial period. Okay, that is 1850 to 1900. Okay, due to the human activities, primary fossil fuel burning, which increases the heat trapping greenhouse gases levels in Earth's atmosphere. This term is not interchangeable with the term of climate change. Okay, climate change is different word. It's a global warming. Okay, climate change means it may be sustainable, not sustainable, but global warming is it's a keep on increasing the temperature. Okay, so this is what happens. Okay, so right now, how much we have the carbon dioxide emission. Okay, so if you see in this graph, okay, in 1979, 92, 2003, 2014, 2024. Okay, this is the actual data. I'm just got it from the internet sources. Okay, so here it was 340 ppm, 360, 380, 400, 420 ppm. Okay, means the carbon dioxide concentration is increasing. Okay, so there was one scientist like Dr. James Hansen. Okay, he already mentioned long back, if humanity wishes to preserve the planet similar to that on the which civilization developed and which life on the earth is adapted, means which is capable to live the living beings like animals, humans, and all. Okay, the paleoclimate evidence that ongoing climate change suggests that CO2 will need to reduce to the almost 350 ppm. Okay, we are already in 420 ppm, but as per his assumptions, okay, we have to come back to 350 ppm. Okay, so this is right now in the 2024. Okay, in 2024, for example, you can take it here. Okay, 2024, we are burning this much of millions barrels of oil. Okay, this much of billions of barrels of oil. So that's the reason we are getting 420 ppm. Okay, but as projected for 2050, we will be increasing, right? Energy sector. Okay, still we are going to means we are going to combust more and more. Means obviously the carbon emissions will be rise. Okay, but as per the evidence, okay, we have to come back to 350 parts per million. Okay, why we have to decrease carbon dioxide? Why we have to decrease the carbon dioxide? Why not other gases? Okay, so that's we are going to address in the upcoming slides. Okay, global warming basically. Okay, we will try to understand what exactly global warming is. Okay, so when sunlight reaches Earth, the Earth's surface absorbs some of the light energy and radiates it as infrared waves. Okay, which we feel as heat. Okay, so these infrared waves travel up into the atmosphere and will escape back into the space, into the space if unimpeded. Okay, so what happens? The energy source from the source is coming to the Earth surface. Okay, so it will be in terms of light or in terms of heat. Whatever in terms of, even though in terms of heat, it will be get converted into infrared waves on the surface. It will, the heat waves will be go back to the space. If it is no disturbance is existed. Okay, so what happens if the disturbances exist? Okay, so there will be what are the particles in the atmosphere air? We'll be having oxygen, nitrogen, and right now we have emission gases also like carbon dioxide, we have carbon monoxide, we have nitrous oxides, we have. Okay, so different emission sources we have basically with along with oxygen, nitrogen, we also we have in the atmospheric air. Oxygen and nitrogen don't interfere with infrared waves in the atmosphere that causes molecules are picky about the range of wavelengths that they interact with it. Okay, see, carefully understand here. Okay, so in this atmosphere, okay, we will be having a water molecules in terms of vapor. We will be having carbon dioxide. We will be having a methane gas. We have a oxygen molecule. We have a nitrogen molecules under. So in this atmosphere, nitrogen molecule and nitrogen and oxygen molecule does not affect the heat is going back to the space. Okay, the nitrogen and oxygen does not affect which is going back to the space. For example, oxygen and nitrogen absorb energy that has tightly packed wavelengths around 200 nanometers or less. Whether the infrared energy levels wider in the wider and lazier wavelengths 700 to 1 lakh nanometers. Okay, so we'll try to explain here. Okay, so what happens? You can see. Okay, so wavelengths here. Okay, 400. Okay, maybe 200, 100, something like that. Okay, 700, 1000 nanometer. Okay, 10,000 nanometer. Okay, 1 lakh nanometer, something like that. Okay, it is like that. Okay, so as I told, if the wavelength is smaller, it is going easily, it will go inside the particle and going. For example, what are the energy we are receiving from the sun? It will be light energy. Okay, light energy we are going to receive. The light energy wavelength is in between 400 to 700 nanometer. Okay, so the carbon particle, okay, because of the low wavelength, the light energy directly it can come to the earth surface by penetrating the carbon dioxide. Okay, this is the logic actually what happens. Okay, it easily penetrate carbon dioxide molecule and the light energy easily can come and reach the source. Okay, but when the light energy is touch the earth surface, now it will be converted into heat energy in terms of infrared waves. Okay, when it comes to the infrared waves, you can see here the wavelength is 700 nanometer to how much? 1 mm, that is 10,000 nanometer. It may be increased till more than that. Okay, that is what here 1 lakh, sorry, 10 lakh nanometer, 700 to 10 lakh nanometer. That is the infrared one. So the heat energy from the earth, it is going back to the carbon dioxide. It has to pass the carbon dioxide layer to go to the space. Okay, when it reaches the carbon dioxide molecule, because of the higher wavelength, okay, longer wavelength, it is not possible to penetrate the carbon dioxide molecule. Okay, it is not possible to penetrate the carbon dioxide molecule. This carbon dioxide molecule absorbs the energy. Okay, so what happens? This carbon dioxide molecule absorbs the energy. So once it is absorbed, so it will vibrate. Okay, so this will vibrate. So when it is vibrate, this is a different types of vibration modes: asymmetrical stage, symmetrical stage, and vertical stage. Whenever it vibrates, it will emit the energy again in all the direction. Okay, once it emits the energy in all the direction, some part of the energy will go back to the space, some part of the energy will again reflect back to the earth. So this is what CO2 does. CO2, H2O, methane. Okay, so this is what happens. Okay, so you can see here carbon oxygen is a O2. Okay, O2 will be having a smaller molecule size. It can easily allow this infrared wave to go escape. Nitrogen also smaller, it will go. So when it comes to the carbon dioxide, it's a longer. H2O is a longer. Moisture is longer. Methane is a compound. Okay, so these molecules, these compounds will not allow this infrared rays directly go to the space. These molecules will absorb the infrared waves, and it will vibrate. Some part will be reflected back to the space, some part will be reflected back to the earth. So this is the reason for the earth's atmosphere getting warmer. Any doubts? This is a very important logic. Any doubts? If you want to ask any questions from these slides, it's most welcome. Okay, so this is what
Dr. Praveen,
yes.
Just sorry for the disturbance in between. We have up to 3:30, sir. So you can, like, you are really in a deep, sir.
Okay, time. Okay.
So that
Okay.
With another
Okay, I will try to. Okay, fine. Thank you. So this is I covered. Okay. So how to avoid the CO2 emissions? Transport. If you decrease the transportation, energy decreasing, food, business, shopping. So if you consume less energy, there is a probability of using less fossil fuels. There is a possibility of less CO2 emission. But we are not willing to that one because we want more comfortable life. We will be burn more energies. That is what our thing. Second thing is photosynthesis. So photosynthesis, as we know, it will require carbon dioxide, H2O. Okay, so this when this react with sunlight, we will be getting sugar, that is a hydrocarbon, and oxygen again. So again, we are working with the deforestation. The photosynthesis, the quantity of photosynthesis also decrease. So that is the reason of CO2 is more and more in the environment. Okay, so what is the other thing? What we can see? So the carbon capture and storage. So what happens? Carbon capture and storage. What happens? So as we know, industries, they will burn more and more fuel. Okay, so this is the source of getting carbon dioxide. As we know from the human activities, why can't we capture the carbon dioxide in the origin itself and try to use it or try to store it some other ways? Okay, so that is what actually carbon capture and storage will try to help us. Okay, so in similarly, you can store or you can use it also. Okay, so that is the two options we have. So carbon capture methods usually will be absorption method, cryogenic method, member suppression method, adsorption method, chemical looping method. Maybe I will take absorption method and membrane suppression method. So this I will try to not much spend time on the remaining part. Okay, so pre-combustion method. So as we know, there is a combustion is required. Okay, so as we know, we need combustion for the energy sources. So what are the combustion requirement? We need carbohydrates and oxygen. Okay, so what happens here? We will be supplying fuel like a coal, biogas, and biomass. We will be supplying oxygen and water also here. So here gasification happens. We will supply the temperature also. The gasification happens. So from the gasification, we'll be getting carbon monoxide and hydrogen. Okay, so when pump this gasification into water gas shift, okay, what happened with the WGS? We will be pumping hydrogen. We will be converting CO into CO2, and we will be keeping H2 as it is. Okay, so now carbon monoxide will be converted to CO2, and we will be having hydrogen. So CO2 and H2 separation will be there. We will take the CO2 somewhere else, and H2 will be pumped into combustion chamber. We will supply the air. We will be getting the pure combustion in terms of heat, electricity, and water is the byproduct here. So CO2 will be separated, will be compressed. When you compress, what happens? It will be changed the phase from vapor stage to the liquid stage. When it's compressed, it will be compressed and stored in some places. So this is the pre-combustion techniques. Okay, so integrated gasification combines. For example, if you integrate this technology inside the gasification, what happens? So this is the air supply. Okay, so in the air supply, we are going to remove the nitrogen, basically fuel, steam, and oxygen we are going to supply in the gasification. We'll get the syngas here. Okay, the slag will be taken out. Again, cyclone separator to remove the ashes and all. So we'll be having carbon monoxide and hydrogen based gases here. We will supply with the steam here, high temperature steam. Again, water gas shift will be taken place. We'll be getting CO2, H2, and H2S gas. Desulfurization unit will separate the sulfur parts. Okay, again, CO2 and H2 will be coming out of the sulfur part and going to get CO2 separator. Hydrogen will be supplied for the combustion chamber. CO2 will be again compressed and stored or utilized. Okay, The next is post combustion. What happens when the combustion chamber is done? Okay, how can we extract? Okay, so fuel and coal baths, again combustion with the air. Okay, flue gases here. Okay, so again we are going to get power heat. Flue gases will be again dust removal. Okay, DNOx and DSOx. Okay, nitrogen oxide and sulfur oxide will be removed over there. Then we'll be pumped in CO2 capture here. Treated flue gases will extract the CO2 capture here. Okay, so that is basically absorption method or membrane method. We are going to use this one. Okay, treated flue, CO2 compression compressed over there. Okay, so again heat and energy. So similarly, so how we are going to extract, what happens exactly in CO2 capture here? Okay, so flue gases is coming here. This is the absorber with the solvents like MEA, DA, MDA. These are the solvents in the absorber. What happens? It will make the rich fluid. Okay, it will trap the carbon dioxide in the fluid, and the treated flue gas will be taken out. Okay, this is the rich carbon dioxide will be pumped into the stripper. Okay, it will be pumped in the stripper. Again, we are going to supply the steam, and we will give the lot of energy supply here. We will take the CO2 and we will take compression and store somewhere. We will use the condenser here. So similarly, exactly what happens in the membrane, again you need you will get the flue gases here, cooling water, compressor, membrane. So exactly what happens, membrane works here like this. Okay, high pressure, mixture of gases, low pressure. Okay, so this is the CO2 particle. Just CO2 particle will be passed in the membrane. The remaining will be taken out. Okay, similarly with the microporous membrane, similarly it works in similar way. So this is how exactly carbon storage, carbon extraction capturing happens here. Only carbon capturing. Okay, so once it is, this is also one of the carbon capturing method only. Again here, CO2 and H2 separation. Okay, after combustion chamber again, and CO2 compression again. We are using similar techniques. Okay, so how much people are looking for the CCS facilities? Okay, you can see the numbers increase. How long the number is in some 2020 to 2021, there is a very big increase in the number. Okay, this is the number of facilities. Okay, so even though it's double, the quantity will be very small. Okay, so compared to this one, quantity will be very small. So right now we are very famous in the US basically. Okay, well, actually what happens, what we are facing problem is CO2 capturing is done. Okay, so once it is compressed, it will be in the liquid form. It's easy to transport in any maybe a railway, road, or shipping method. We can transport it. After that, we can pump it deep underground. Okay, and storage it. Okay, we can store it. So what is the drawbacks? Basically, we have to spend lot of money for the capturing. Okay, you need additional support, additional system. Okay, additional energy. Okay, so these are the things you have to penalize to the society to make it. Okay, the second thing, whatever we capture and stored here, we have to make sure that it will never have any vent holes or some other damage, or it may be create some problem with the earth platelet also. So this may be the another issues what we have with respect to CCS technique. So this is what just I want to convey. Any questions? At least people, it was useful, something interesting.
Dear participants, if you have any queries, questions, please you can ask to Dr. Praveen.
Maybe you can switch on your cameras. At least we can see our faces each other. Somebody's.
Just a minute, sir. I'll turn on their video so that they can switch on their camera.
I hope it is not so boring. At least.
Hello.
No, sir.
Okay.
Sir,
Any
namaste.
questions? Okay, at least 5 minutes I'm ahead. Okay, fine. 5 minutes we have for the discussion.
Praveen sir, namaste.
So, namaste.
Parashram Chitragar here.
Yes, sir. Nice to see, listen from you, sir.
Yeah, nice to see you then.
Thank you.
Presentation and as well as the work carried by you and as well as the content delivered by you. It was of up to the mark, sir.
Thank you.
Yeah, only just I wanted to say those
Yeah,
words. Otherwise, I don't have any questions.
Okay,
Great
thanks.
work, sir.
Just I want to convey one last message here. The water. Okay, so we people work with the refrigeration also, right? Why the refrigeration is required? So basically, we want to extract heat, okay, from one place, and we have to deposit from other place, right? So water is exactly work as a natural refrigerator for the earth. Okay, so whenever the temperature rises, what happens? The ice which is accumulated in the South Pole and North Pole, it started melting. Okay, it receives energy, heat energy, it started melting, means change of phase will happen. Okay, and it will be making to liquid form. Okay, it will receive the energy. That also one of the reason right now the temperature is not spiking so sharp. Okay, but when we lose lot of ice, okay, when we lose lot of ice means we will be having a more accumulated heat energy in the earth. Okay, so that will again cause very big problem in the future. So this is all the symptoms what we have to see in the our environment. These are the like warning signs for from the earth actually.
Dear participants, if you have any queries, please ask to Dr. Praveen here. Even if you have more questions, you can ask later also. I'll provide the details.
And if you want to tell something to me, even I am ready to accept the things because I want to learn also.
Hello. Hello, Praveen sir.
Hello.
Yes.
Yeah.
Yes, sir. My name is Dr. Satish More.
Yes, sir.
Yes, sir. Your presentation is really nice and attractive slides you prepared.
Okay, sir. Thank you. Thank you very much.
And I think all the data, whatever you have presented here, that is in up to the depth. So it's a very good presentation, and thank you for your presentation.
Thank you, sir.
Dr. Praveen, I would like to thank on behalf of organizing team because you have started with the energy and even the constituents of all the air, atmosphere. So normally we talk about the climate change or the energy, but what exactly happens? Because the basics, which is very important to understand the applications and also the mitigate the things. So you have really shown the very deep knowledge. You have explained to our participants, which will definitely help all the participants so that in future, so they will be the part of the saving the energy and even maintaining this ecological system in a balanced way. So even you have explained nicely regarding the carbon capture, which is one of the most important thing right now. All the researchers or the researching group, they are working on that. So I really thank you, sir, being a resource person to this FDP. In spite of you have given the almost 1.5 hour your busy schedule. Normally, dear participants, I used to interact with Dr. Praveen. So he'll be more interest regarding the discussion of the philosophical as well as the research oriented. So he's not only in the mechanical, he's the all-rounder. He's not only the engineer, he's a PhD postdoc fellow. So if you have any doubts, queries regarding any things, not only the mechanical, if you ask any queries regarding the electronics also, he's ready to explain the things. So such type of expertise we had really, it is our pleasure. Thank you very much, sir.
Thank you. Thanks for everyone for their time. So it's my pleasure to be a part of this session. Thank you. Thanks a lot.
Welcome, sir. Dear participants, now it's the time to move the second session of today's FDP. We have the session chair, today's session chair, Dr. Tabish Wahidi. Dr. Tabish, you can hear me? Can you hear me?
Yes, I can hear you.
Yes, sir. Yes, sir. Okay. Today we have the second session on the human comfort and the climate change by Dr. Tabish Wahidi. So as we had this resource person, he was a resource person for us to explain the battery thermal management system. So even I'm not going in detail of introduction regarding Dr. Tabish Wahidi. Sir, I welcome you again for this session. So we have 3:30 to 5 p.m. So you have 1.5 hours. The session is all the forum is open for you, sir.
Okay. Thank you, Praveen. Thank you, Madhu. And by the way, Praveen, it was a nice presentation and a different aspect to listen and understand the carbon capture technique. And welcome all the participants. Thank you, and thanks for listening me again. Get ready for this different topic what I'm going to deal today. So can I share the my slides? Let me know if it is visible to all of you guys.
Yes, sir, it is visible.
Yes, sir.
You can proceed.
Okay. So as the topic suggests, I need gonna talk about what exactly the meaning of human comfort and how your climate is gonna affect your human comfort and sensation. So I'm gonna dive deeper on this. Only the perspective of thermal stimulation, how you're gonna do, what are different techniques, what we have to consider when you're gonna do the thermal simulations. It is not like such a simulation where we do generally do with the help of CFD only, or you may have a thermal way of doing that. Here we are gonna try to understand the human behavior of it. So it's like 1 minute, so because I'm getting some lag in the just make one switch off this video. Am I audible to everyone perfectly? Hello?
Yes, sir, you are audible.
Okay, thank you. It's okay. So here we're gonna give you some brief information about what exactly human thermal simulation is, uh, and how it is, how it works actually, what are the different factors affecting it. If you talk about the different factors, we need to consider the environmental effect as well as the human physiological effect. So why these two factors are important to us, what are the physics behind this, why we need to consider this when you're trying to understand your human thermal simulation. I'll try to give you some information about the advancement in human simulation, how people come up the simulation when they consider different scenarios, when they have to do this simulation, uh, considering a human in a very adverse environment, a very cold environment, or a very high environment, wearing different type of clothing systems that will take into consideration. And even for individual, like is whether a male and female, what is his body mass index, what is his body size, what how much height, what is his height, everything that we need to consider in advancement system. Then I'll give you a brief information, little bit of brief information, why we need to consider the battery model and what exactly it is, why it is needed for everyone to when you try to understand human thermal simulations. Then try to understand with few examples, few case study what we have done earlier with different clients, and then we'll try to conclude with the summary. So we'll try to understand what exactly human thermal simulation is, why we need to do this, what is the major factor, and that we need to consider when you are trying to do the thermal simulation for human. So try to understand here a human for human, what are different factors that may come into picture. So your environment will come into picture. What is your convection rate is there, what is the evaporation happening from your body, in which, if suppose a human is standing or sitting somewhere driving a car, you're holding your steering, you're sitting somewhere, so your heat may get observed from the nearby objects to human. Apart from that, it also matter what is the environment condition outside, what exactly at environment condition you are standing, whether it's a very cold place or very high hot place, or it's a normal environmental situation where you are standing or you're doing some performing some activities, the human is performing some. Based on this, we trying to understand humans local comfort, local sensation, local um, his local body temperature, his overall body temperature. So all these will factor the human comfort, it will decide human comfort and session. Apart from this, we do have to consider a lot of things. Okay, like what is you, how your body mass, what exactly your size is, whether you are a male or female, what is your body mass index, how fat you are, how long you are, what type of clothing you are wearing, what type of body activities you are performing, how long you are doing some activity, whether you are sleeping, you are driving a car, or if you're going to gym, how rigorously you are doing a gym, and from how long you are doing a gym. So every aspect will come into picture when trying to simulate the human, try to understand a human behavior in the sense of thermal simulation, whether human is comfortable or not, whether he's feeling sensation, sweating, shivering, what is his blood flow rate, what is the overall body temperature, hypothalamus body temperature, hypothalamus temperature. Every come will depend on these activities. On depends on your body size also, your activities. Now we'll take some situation. Suppose uh, consider a man sitting in a car, and there is a solar loading coming onto dashboard, and heat is getting radiated from these positions, and you are having sitting in a your seat is not comfortable, it's also radiating heat to you. Or you may consider a situation where your flying airplane is flying at a very high, high altitude, at very high velocity. Your thermal conditions are different, your weather condition keep on changing everything. You need to regulate all these things, and what is very important is your environmental situation. Environmental situation always impacts more than all these situations what we are feeling. Apart from, because in this your solar loading one came into picture, how fast you are running, what is the outside environmental condition, is this a long, very hot temperature, or is it a cold weather condition, or sometime it also depends how much humidity is there outside. So all these factors regulate your human typical energy budget, will decide your the energy budget lost by human things. So generally by cog doing something research on human energy budget in 76, we found that maximum 60% of energy is lost by the radiation, 25% by the evaporation, 12% by convection, only 3% is by the conduction. So considering all your situation, your environmental condition, your where you are sitting, what type of wearable you are wearing, what is your body mass index, what is your anthropometric information you have, what the gender you belongs to, everything. The main factors come into thing is to make a human comfortable. You make a human happy, so that your situation should be created in such a way that if you are sitting in a car, you feel comfortable. Your HVAC system will be optimized in such a way that you will feel happy. So considering all this situation, we need to perform human thermal simulation. So, okay. So if you talk about human thermal simulation, we need to consider two major things. One is your short wave. So it's a situation when your radiation science in human skin. So there are two type of wavelengths will come into mainly consideration when you try to calculate the human thermal. One is your short wavelength. Second is your long wavelength. In short wavelength, generally what happen, your maximum large portion of your radiation is get deflected, almost more than 70% is getting reflected from your surface. Only rest of the get penetrated to the skin. And also we have to define which skin layer, whether it's going very deeper or only get absorbed by the upper layer skin. Like in for long wave, generally only few are get reflected, hardly maximum are getting absorbed by the upper skin layers. So all considering all this, so every wavelength has a different impact and a feeling, which make human thermal simulation very sensitive, and it will help you to decide whether human is in comfortable position or not. So define what exactly comfort is as per the ASTRE standard. ASTRE tell that a thermal comfort is a condition of a mind that express the satisfaction with the environment. If your mind is feeling satisfaction, if in spite of whatever the environment you are situating, suppose a guy who is from Russia, he got habituated to standing long in a very cold weather. Okay, if we come to now in North India where the temperature is around 7 and 8, he'll try to feel very comfortable. For other guys, it's like we are shivering. For them, it's comfortable position. So it's all about the express of your mind satisfaction. Okay, although the environmental condition is same, both are human, but the satisfaction level is different. So based on that, your only comfort level is being decided. Now, we'll try to understand the flow pattern, how a thermal simulation can be done. To do this, you must have all these things. You must have a situation where you have need to consider your thermal conductions, convection, radiation, and environmental loading. That's environmental loading comes with a weather condition. So weather condition means suppose a man is in Siachen, and on we try to calculate his thermal comfort on 15th of December, where the weather is very adverse, or wind speed is different, the direction of is different, your solar loading condition is different. That we need to consider when trying to understand human thermal simulation. Then there must be a human model. So these will go on hand. This like a coupling thing. Apart from the conduction, convection, radiation, and environmental condition, a human model has to be there. There will be associated with some equation that will come into picture. If you do coupling with these two things, if do the coupling with these two things, then you need to calculate the what is the equivalent temperature of that one. What is mean radiating temperature? What is percentage of dissatisfaction? Based on that, we also also it will help you to decide which environmental condition you are taking. Are you considering only environmental model, or you also considering the physiological model? Based on that, if you're trying to calculate all these, which will help you to decide whether human is in comfortable position, what is the sensitivity, all these is called as your human thermal simulation. So it's like a flow. Okay, so there are a lot of solvers available in market which only help you to decide whether it's a human thermal simulation or not, like thesis, Thytom, or Twilala model, or there are so many things in market that will help you to do the thermal simulation. So if talk about the environmental and physiological approach, that is very important when you have to try to understand the deeper aspect of why these two things is very important when trying to do a thermal simulation for a human. So in this condition, we'll try to understand the environmental approach. So environmental approach is like a situation where you only consider the environmental approach. Like a situation, you kept your car outside and you're trying to understand the solar loading on it. What is the surrounding temperature? What is the air temperature there? What is the air velocity there? What type of human resistance is there? What is the human humidity there? You're trying to understand every aspect of environment only except the human is sitting inside, considering that if environment is comfortable, a human will be uncomfortable. So it is like a understanding. It's a backway understanding. If human is outside, is weather is comfortable, he will feel comfortable. This is also an approach. So we called this as an environmental approach, but we call it a black box approach. Why is a black box approach? Because a man, for you, maybe a weather outside may very cold. For other guys, it may be a comfortable. So we need to consider the human aspect. That is called physiological approach. In environmental approach, we only consider the environment condition. So based on that, also we have a method to calculate whether human is comfortable or not. That is being predicted by two generally method. One is called PMB method. One is called PPD method. So based on this method, they decided a 7-point standard regulation. Suppose this 7 point from 3 to -3, if somebody is situated at 80% ppd, 80% ppd, that means human is at -2, so he may start feeling very cold. If we come closer to 0, okay, or like around 5% of ppd or 7% of ppd, he will feel neutral conditions, not very comfortable or very warm or slight warm. So based on these 7 points, we can indirectly calculate that the human will be in comfortable position. This is the method of calculating with PMB and PPD. Apart from PMB and PPT, they do also have a approach called as equivalent temperature approach. In this situation where we need to balance, what does actually the balance mean is, like outside temperature is human temperature, body temperature, and outside temperature is both are getting matched. Just outside like homogeneous situation we are creating. If we both this situation is getting matched to each other, if your things are getting already balanced, then we can say this human will be also in comfortable position. So all these are the way of calculating, understanding human thermal simulation or comfort level based on only calculating the environmental approach. But we do have an option to do the calculation based on human, keeping the human in that environment. that will call as a physiological approach. So it in this condition, apart from your basic environmental thing, will keep the human inside and will try to calculate the human comfort based on this environment. So it is like environment plus human. So that is why I call it as a physiological approach. So it is not a black box approach. Is here we need to consider human physiology, his anthropometric information. We need to consider his skin temperature, core body temperature, evaporation rate, and explicitly we need to calculate some discomfort and sensation level. And these sensation comfort levels are being calculated by very different models. One is a ASRE 2-node model, one is called Philalal model, Xitadel model, and with a very famous model we have known as a Berkeley model. This anyway, I'm gonna deep dive in this Berkeley model, what exactly it is, how why need this model is well accepted around the world to do the calculation for a human. That will come in a coming up slide. I'm gonna discuss this again. So when you try to do the physiological approach, there is equation working. This is called a bi-heat equation, where your conduction in a tissue will come into picture, then your advection in blood, your metabolic activity will or metabolic activities, metabolism will come into picture, your heat transfer from environment, and the energy storage. So all these will, apart from environmental condition, all these will come into picture when you try to do the thermal simulation with physiological approach. So with physiological approach is well accepted model and widely used around the globe. People trust more in this approach rather than environmental. But the environmental approach is quite simple, and we can indirectly understand if outside sensation is comfortable, human will comfortable. This may happen sometime. So it's no one, I can't say that environmental approach is wrong, but if we try to consider which is the better one, the physiological approach is better than the environmental condition. And for this physiological approach, they have defined a scale which will define your human, whether human is in comfortable position or how comfort he it is. Like for environmental calculation, SRA defines 7 point. Here in this approach, it is a 9 point scale. So in 9 point scale, it varies from +4 to -4. Same goes with comfortable also, and 0 they kept for the neutral condition. 1 is for slight warm. So sensation and comfort is like a feeling. Okay, so condition look like a human. If your sensation is more, if your comfort is more, your sensation will be less. So it's not like that. They have different approach also. Like a condition, suppose you take an example, you are outside, all of a sudden you came to your home, or you kept your outside environment is very hot, you kept your head inside a bucket, a cold water bucket, you start feeling comfortable. Your sensation is high, but you start feeling comfortable. Okay, so we need to understand what exactly it is, what is your sensation and what is your comfortable. Okay, this is a 9 point scale, generally used to understand the human physiological calculation, to understand human comfort and sensation. And this is this model is adopted by Berkeley Comfort, which is developed in University of California to calculate human comfort and sensation. Now coming to this comfort, Berkeley comfort and sensation, what exactly it is, how it works, what is the basic physics, how then it is going to calculate your sensation cases. So if you try to understand what exactly Berkeley model is, this model is being developed, developed in University of California, located at Berkeley. So they called as University of which like called as a Berkeley model, and this is being developed by a bunch of researchers, those who are working under the Professor Zhang. So there was a like collaborative university developed well accepted model. So this model actually take into consideration about your local sensation, your local comfort. These two things will decide your overall body comfort and overall your sensation. This will like so that your body may feel overall comfortable maybe, but you may feel a situation where a particular portion of the body is feeling chill. Like suppose you are driving a bike in a very cold condition, you are wearing jacket, everything is fine, but you're not wearing gloves while during driving. So your body is overall comfortable, your hand is not comfortable. So you locally you are uncomfortable, overall you are comfortable. So we need to calculate your comfort and local comfort or local sensation too. Okay, so this local sensation depends on so many factors. So local sensation is factor of your skin temperature, the rate of change in skin temperature, rate of change of your core body temperature. Everything will come into picture when you try to understand the local sensation, and as well as this your this local sensation will define your local overall sensation, and this overall sensation will define your overall local comfort and overall comfort. So little bit confusing here. I'll try to make it more clear in this situation. So it's like you have a local sensation, this physiological result. So because of your local sensation, your overall sensation will decided, and this will try to give you information about the local comfort, and also overall sensation will try to give you information on the local comfort, and this local comfort give you the output of local comfort, overall comfort. So this is like, although your every body parts have a different behavior, you may have come across overall comfort level, your head comfort level will be different, your local comfort level will be different, your local sensation temperature sensation graph will be how it is varying transiently, that you can calculate and understand whether if you are in very minus zone, suppose this darker blue line is in minus, that human is feeling comfort, any one of the part of body is feeling very uncomfortable, right? Rest of the part, few of the parts are feeling comfortable. Then based on that, few parts are comfortable, few parts are uncomfortable. So based on that, we can decide whether human is overall comfortable or not. Okay. So this is the way to calculate the Berkeley method, is a way of calculating the Berkeley method to decide whether human is in comfortable position or comfortable, what is sensation. So I'm Hannah, in this upcoming slides, my intention is to give you information of advancement in human simulation, where we need to consider, apart from some few things that we already talked about, what are the different things, what are different approach that will be a realistic situation, or you need to be considered, always you need to consider when you're trying to simulate the human comfort. I'll give you a situation. Look at this one. So apart from your basic calculation, you must need to define your physiology of a human, what exactly the human is, what is body size, what is his height, weight, what gender he belongs to, what is anthropometric information, what type of activity he's doing, what is the activity level, like whether he's driving a car, or from how long he's driving a car, what is whether if it's suppose he's going running, to how fast is he running, during what time he's running, whether it's a male is running or a female is running, what the body size he belongs to. So your physiological aspect need to be considered when you try to understand the human thermal simulation. Next will very important thing will come into picture is your clothing, what type of clothing you are wearing, what is the GSM value of your clothing, what is the thermal resistance it is, what is the evaporative resistance, are you wearing a cotton cloth, are you wearing a woolen clothes, or standing in a hot summer day, or you are wearing a cotton cloth standing in a very cold environment. So, and what type of layer material, clothing layer, which is a single layer jacket, multi-layered jacket, what type of material has been used, what is the thickness of that material. So we need to consider this situation when trying to calculate human physiology, human comfort and sensation, and his body part temperature. Again, we can't neglect this situation. What is important is your environmental thing. So to do the consideration of your environmental, we need to understand what is the radiation happening around. Are you sitting inside your home, or are you talking about going outside condition? What is the wind speed there, and how, at what height from sea level you are standing, whether you are very close to a sea level or you are at a very hill station. So wearing all, even though you may have a same body condition, body weight, those who guys belong to a sea level, although you are wearing you both are wearing the same cloth, but your height level from sea is also coming to picture, because your weather condition will be different, your wind condition, every solar loading condition will be different. So all this scenario, when you keep all this scenario into one picture and try to understand human thermal simulation or human comfort simulation, trying to put all this together will give you much more realistic information, and you may understand how whether in these conditions whether he will be in comfort position or not. Okay. So this, based on that, you can decide what will be human condition, what is body core temperature, what is the hypothermic temperature, what is the what type of no, what is the blood flow condition it is, what is his convection rate, what is his evaporation rate, whether he's feeling sweating or shivering, what is his evaporation condition, what is his dilation condition, what is his other rectal blood flow temperature. So all these, after simulation, you may come across all these information, and based on this temperature distribution that can be carried out, especially obviously you can't do a steady state analysis. You need to do a perform a transient analysis for a period of 5 hours or 10 hours, or suppose a soldier is standing some outside holding a gun at Siachen. So if after 5 hours of regular standing, his body temperature will be different, his shivering rate will be different. If he is wearing a comfortable clothing system, so his body condition will be different. So that is called completely a transient thermal simulation that we always keep in mind when you do the consideration. It will be a complete transient simulation. So in upcoming slides, I'll give you some information about the case studies or different conditions where we try to create a scenario, and we'll do the simulation by based on the information available and try to understand if it is the situation whether the human sitting inside a car or inside standing outside or doing some activity, whether it will be a comfortable position or not. So few case study that are trying to give you information. So this is a case study which been done long back. This is a situation we call as environmental load condition, where we have a human sitting in a car, and your environmental condition is completely changing. We have 6 different scenarios where a condition where you're trying to you switch on your AC for a time period, or your it's a one of the situation is that your car is kept outside, is a heat soak condition. And one condition is was like your complete environment is changing very transiently changing very high, that is going high temperature to low. So that's just what all these are the virtual condition we created to understand human comfort level. And in this condition we're trying to quantify what will be your blood flow rate, what is body temperature. If you're trying to keep on changing your, suppose you're trying to change your uh, car speed, or you're trying to change the glass of your car. Suppose you are using some different insulating different type of glass material, and trying to evaluate what in the same environmental condition, same solar loading condition, if you are using a insulated glass or a different type of reflective glass, or some solar radiative glass. So whether human sitting inside, whether it will be comfortable or not. And if you try to change the airflow rate, ambient conditions, all these situations we created to understand different variables keep on changing to understand the human comfort level. So these was a very is a very elaborative, exhaustive study that been carried out to make human give them a data that based on these variables or these adverse condition, your human will be comfortable during this zone. You need to do this type of thing to make human comfortable. You do some design modification, you need to use a different type of glass, you need to decrease your insulation, or you may need to increase your insulation, or you need to increase your air speed or HVAC system optimization to make human comfortable. All was the cases where we consider only the some environmental load to do the analysis. Some others also case study there. This is a case study that we recently carried out 1.5 years ago, where where the client told us to perform an activity. They have a van where it's a 7-seater van, and all these human guys are for different body mass index. They have different weight, height, everyone is sitting inside, and they have a, considering that they all are sitting, simply sitting, not doing some any activity rather than only sitting. So based on different body sizes, so it is like a multiple body multiple occupants are sitting in a car, and we try to understand what will happen. We try to will happen, and what will be each main of a different body size, will whether he will be in comfortable position or not, or what is comfort and sensation level. So we created scenario. In this scenario, we kept your vehicle outside environment from 5 a.m. to 12 p.m. and it is a hot desert condition. So your vehicle is empty. If the condition is like as a heat soak condition, your car keep on absorbing a heat. Okay, and then we pull on the AC, pull down the AC from 12 p.m. to 12:45 minutes of condition, and based on that, we incorporate the weather condition of that that location. Actually, it was being carried out for Rajasthan location, so where the solar loading condition is varying. You may find very high temperature around 12 o'clock in this peak. That is been calculated, and then we try to understand each human body, what his front lobe guys will start feeling, what will the second row guys start feeling, what is the body temperature, everything, and we'll try to evaluate the result with a different body mass. So, and based on all these different body mass and guys who are sitting at different position, we try to evaluate his overall comfort level. So based on that, we evaluated that the man who is sitting body mass index of 85% is very uncomfortable. The guy who's sitting somewhere back, okay, and his body mass index is 85%, so he's feeling very uncomfortable. The man who's having body mass index of size of 15 is feeling comfortable. So all these are different occupants information in a single car. All are doing same activity and trying to understand the each human behavior at different uh, okay if you have a different body marks in this. So this simulation give you information how you can perform thermal simulation even though different occupants are sitting in the same environmental condition, and they all different guys may have a different feeling, the different comfortable situation, they have different sensation. So this case study was being carried out for multiple body size. Now one of the interesting case that we carried out for a military tank, this was like you kept your vehicle outside your, this was you kept your vehicle outside and try to understand the solar loading condition. It's a pretty hot soak condition where your vehicle is switched off, is simply kept outside, and we try to understand because of this high heat temperature what is being absorbed within 24 hours, and what will be your hot spot, what are the areas where it's getting very hot heat, and what will happen when you kept your vehicle even at night, what are the moon coming out when your vehicle, and trying to understand the thermal radiation of this one. So and based on that we'll understand if suppose any enemy is trying to watch your vehicle from some distance. So based on your thermal thermal calculation, thermal signature, what will be the chances of your vehicle to be identified at a certain location, what is the probability of detection of your car. So if you suppose your car is getting very hot heat at particular position, like suppose in this area, do we have a technique or do we need to do some mitigation technique so that you can your thermal to avoid or mitigate thermal radiation in a particular position. So we can do a shielding method to avoid, to reduce your thermal signature, or we can go technique which that is called camouflage technique. You paint your surface in a such a way. Generally we found they are all army guys are different, no, we call it just a army shirt or army pant, or is a army soldiers dress, because they have a different pattern, and every soldiers those are working at different location, different places, they have a different pattern, so that they got camouflage with the situation surrounding and not easy for any enemies to identify. Okay, so this was a study for identify the military tank and try to understand human. If you kept your human inside, for a 24 hours, what will his body condition? We did the calculation for that also. Now, one of the interesting thing was a case where we tried to understand the situation. It is like you kept your vehicle outside, okay, and the human who drove the car and went to office, sit for 2 hours, started working, although your car is was kept outside, okay, and after 2 hours of working, you came inside and start driving car. All of a sudden, when you entered your car and you switch on your AC and you try to drive with a speed of 50 mph at particular direction with maximum AC on, so how much time will it take to make human comfortable? That was the analysis that need to perform, and how much time it will take human to reach to a comfortable or less sensation situation. So this was the situation where you have a human and different loading that we need to consider when you are driving a car at a particular direction. What is the solar impact? What type of heat is getting coming out from your dashboard? What is the heat getting absorbed from the upper panel? And how much heat is getting radiated from your seat to human, and human what he's wearing? Based on that, we calculated, and give them a suggestion. So how your HVAC system energy management has to be, how much you keep your AC to be on, what the exact location of your AC, so that human will feel comfortable. What will be the size of HVAC system, how will be your flow rate for your gases coming out, cool gas air coming out from your HVAC system. That was a case study. Now, one more case study where we have to do the analysis, understand a human sitting in a electric vehicle, and because of your fast charging condition, or maybe a condition when your vehicle may go run away. So all these will impact high energy or impact very high heat transfer to your vehicle. Your vehicle will start lot of heat already during your driving condition. Your battery get temperature increasing, okay. So based on that, and the human sitting inside is feeling hot condition because of the heat getting transferred from the battery, the floor, and from floor to the human. So how long your battery will be active when your HVAC system is switched on, and trying to give a comfortable stay or comfortable less sensational situation to human. If your batteries start draining, your HVAC system is start using your HVACs, using energy from your battery. So what will be the happen to your range also, that when you have your cars already in a environmental condition, that solar loading is already coming to when you are driving the condition. So all this, how will gonna this impact to your what you call this range to the battery, that we have calculated. So it was like a trade-off situation where we had need to understand the human thermal simulation, as well as needs to balance the energy management of a battery, so that your battery range should be good enough to predict a situation that you can promise, okay, from this much charging you may make vehicle go up to this kilometer, and you can even for a switch on condition of AC. So all and your human sitting inside will feel comfortable. That was the situation when we trying to do the calculation for this. This was like a battery energy management along with the human. So this study that I'm going to discuss was like a glass modeling study. So you have a two glass. One is a standard glass for a standard glass, and one we have a solar reflective glass around one all these things, and we have a solar roof there, and the thickness is kept for both the glasses are same. The specific heat for the glasses are kept same. Conductivity, density, everything is same. Only the difference is in their reflectance and transmission properties. The reflectance of this mic is a little bit higher. Reflectance of the standard glass is less. Transmission of this one is high. This one is less. So if you have a glass, a standard glass, and a solar reflective glass kept in your vehicle, and we're trying to understand human, suppose 3-4 human are sitting inside, and what will be the heat being observed when you have a solar soak condition or you are driving at a particular speed. So if suppose you kept your vehicle and trying to understand because of solar loading how much heat is getting absorbed at particular situation. So in both condition, you try to run a simulation for a period of first you need to run in a steady state. We try to evaluate the overall body temperature, the temperature coming out from the bonnet, the temperature coming out from the underhood thermal management. Or this vehicle is like a IC engine, the traditional IC engine. So how much the energy is or heat is coming out from the exhaust system? What is the effect of this exhaust system impacting on your floor, or how much you complete because of solar condition, how much energy is getting absorbed by each part of the vehicle, that we need to calculate first. So and we try to differentiate when we have a standard glass and solar reflective glass, and then based on that we'll try to understand how much energy savings can be done if you have a solar reflective glass or if you have a standard glass. It's a comparison of this, and this being carried out for the scent go bean. So when you have we try to understand the inside temperature when being kept in a solar loading conditions, what will be the inside temperature? Okay, where the temperature is high, where the temperature is low, whether solar reflective glass temperature is high or not. So you can find a little bit of inside temperature difference. Yeah. Okay. Hello. Hmm. So dashboard temperature in this solar condition, the standard glass is very high. In this condition, it is little bit less. So all these we try to calculate, and based on that, we did a analysis. So in this standard glass, you can find the inside temperature is very high compared to solar reflective glasses. Okay, and that means your it is suggestible that you can have a you need to replace and come up with a solar reflective glass will give you a better mm, mm, better temperature distribution compared to standard glass. And then the human sitting inside, we need to calculate which one is in a better condition. So if you have
Uh, uh,
yes,
Tabish, your PPT is not visible.
my PPT is not visible.
Yeah. Just you can share one second. Yeah.
Is it visible?
Yeah. Now it is visible. Thank you.
How long it was not visible?
No, just now. Just now. 1
Have
minute.
you this slide?
With this slide only, it was not visible.
Okay, it's okay.
Okay.
From here, okay. So from okay, sorry, it's my mistake. I don't know how it happened. Okay. No. So based on your solar load condition, we try to evaluate what will happen when you have a comparison with a standard glass and solar reflective glass effect. We did a complete steady state analysis and just trying to understand the complete temperature distribution across all the full vehicle model temperature. What will the temperature of your upper panel? What will the temperature of dashboard temperature? What will the temperature inside of your car? So you can find a little bit of body temperature difference. Outside is quite common because both are exposed to the solar condition. That's why all these outside temperatures are similar. Both the condition is same. You will find a difference in these areas. The inside car temperature in this condition, suppose especially for the dashboard temperature, because in a standard glass, your temperature is a little bit higher, while in solar reflective glass, your temperature is less. In this situation, what we carried out when you have a solar reflective glass of different reflective index on a different transmittive values, and based on that we try to find out the overall inside temperature. In standard temperature you can feel all the, even because of standard glasses, your floor temperature is also higher, but in the solar reflective glass your temperature is less, your steering temperature is also less. In reflective area, your seat temperature, surrounding dashboard temperature, your panel temperature, your electronic equipment temperature also less in solar reflective glasses if you use. So it is suggestible to go for this reflective glass properties, and then we try to evaluate if all this situation, what will happen human is sitting inside, whether they will be in comfortable position. Okay, this car temperature is high. Now we have to understand the human those are sitting inside, whether they will be in comfortable position or not. Okay, so based on that also we have sorry, so we calculate the human inside. Okay, but when you try to understand these temperature, although these temperatures are very high and all, the human sitting inside have a different body temperature too, but backside you won't find a much difference. Okay, backside guys are almost a little bit almost the same temperature, but may they have a effect of this maybe a little bit less. So the situation is even when we try to calculate the power of energy consumption in solar glass and standard glass condition, it was like very huge. This in solar standard glass energy consumption was very high, while you have a solar reflective glass your energy consumption was also less. So it was advisable for them to use this glass property to use in car. Now we have a very interesting case when we started working with the DRDO guys. They gave us a situation. Uh, a soldier is standing in a environment where they have solar loadings. Your different sky condition was different. They are standing in a very cold weather, and their terrain conditions are different, and ambient temperatures are different, and they all are standing holding a gun. You find all these difference, and then we try to calculate taking a standard human. Based on all these conditions, we're trying to find it out the human thermal solution. What is his thermal signature will be. So all after doing all this, considering human comfort level, human sensation level, considering the environmental condition, weather condition, the position he's standing, how long he was standing for 5 hours, it was being done for the 5 hours, and for a weather condition of at as a low temperature condition. So we found a temperature distribution of human. This is a human soldier signature. Okay, this thermal signature, because of your IR cameras, any enemy or any your enemy will sitting at a certain distance will try to find the human, or trying to find your what called as a defense asset from a long distance, and identifying whether human is standing there, what he's holding, whether he's holding a gun or he's holding some other things, or what type of tank model is this is situated at that base camp, how many human are there, and they try to evaluate the thing that is called probability of detection. They give you they it will give them an idea that this human is 80% visible. This situation, this in this situation your tank model is 70% visible. That is called probability of detection. So our intention is to do the thermal calculation first, trying to come out how much thermal signature is coming from the soldiers. The next stage is to identify human and give them a particular clothing system with different emissivity of surface, and try to make a human soldiers condition with different clothing pattern, we call as pattern, and then try to evaluate the human signature at different waveband. Okay, so the same situation where you change the clothing system of a human and trying to evaluate the human with IR bands at different wave band, like the short wave band, how much human is visible, which portion is visible more at near wave and mid wave band, how much the human is visible or the shoulder is visible at long wave IR band, how much human is visible. So at different wave band, we do the calculator to give them a result, and this situation gave them an idea how whether in this wearing this clothing system holding an gun, if a human is trying to camouflage with the background, if you can find it, you can whether if you try to find the way human is shoulder is standing somewhere, okay, is completely almost like a camouflage with the background. Okay, is not visible easily in short wave band, is only slightly visible in long wave band IR. Okay, so that this thermal simulation give you whether human who's wearing a particular suit at standing in a particular weather condition, whether he is feeling comfortable or not. If he is feeling comfortable, okay, this is good. Then wearing this clothing system, how much thermal signature is coming from the human, and based on this thermal signature, how much portion of human is visible at different wave band. Okay, and which wave band human is more visible. Okay, so this, and whether in this wave band, whether we can camouflage with human with the background, is it possible or not? So all these being carried out now. So one of the very interesting case what we called, we did it for one ordnance factory. Those who are in a comfort level calculation of human, they have a situation where a soldier who is wearing comfort, high sense thermal comfort clothing, especially for the Siachen areas. Okay, so they have generally 4 to 5 layers of clothing system. From they call as level 1, level 2, 3, and 5. In between, one more is there. They called as a level 4. So after wearing all these clothing system, we need to find it out how much, whether do we have an option to increase or decrease the thickness. If suppose you want to increase the layer of insulation there in jacket, you have a 2 3 layers, whether it will work or whether we need to change the material to make more comfortable. Do we have an option to replace the material with a new material and a lightweight material but a more thermal resistant material that human will don't have to wear a very high weight garment, but even though at low weight garment human soldier will feel comfortable. That was the task being assigned to us, and they have given some properties or GSM values. So what is the thickness of that one? Outer layer gloves, socks value, boot value, face clothing values, fur jacket values. What is the thermal resistance value? What is the evaporative resistance? All this value. Based on that, we need to calculate the situations. And one more interesting thing happened when they try to create a scenario. It's like a surgical type of scenario when human is like jumping from a height, wearing some special suit. Then he has to run for almost a 100-meter fast run. Okay, and then he will hide somewhere, some places for a minute and two. Then he will walk down and try to find it the enemy base camp and try to these all activities. So based on all these situation, how which type of clothing will be the best for them, what type of thermal insulation we have to provide. So considering all these activities and the level of activities and duration of activities, so you need to perform the simulation and find out the human thermal result, so that it will won't be identified from this different web band, and human will feel comfortable and sensation and result that is very needed. So all these, based on this, you need to perform a number of iteration to finalize the what will be the clothing system. Apart from the previous case, they have one more added case to us. Now, to optimize, you may have to perform 2 3 round of simulation to perform. So for to perform this type of thing, you must have a CAD model. You take a dimension of the CAD model, what they suggest of 6 feet human being. Then from the CAD model, you convert it to a mesh model. From mesh model, they're trying to give them a clothing around this, like human is wearing a boot, and then his 5 level clothing system is gloves. He's wearing a glove. So considering all these clothing over the human, you try to perform the simulation. And this simulation we give you a overall comfort and sensation information. So based on that, we can say that human wearing all these clothing system, human is not feeling very comfortable. Overall sensation is very high. You feeling is very cold condition. So these are the result what I'm sharing today. That means we need to come up with a new plan. We come up with a new clothing system, so that after having a 5 years of activity there continuously, human will still feel chill, because your environmental weather is very harsh. The temperature is around -35 or 40, and ambient temperature is also your ambient wind temperature was also very low, and wind speed is very high at that time. So based on that, even if human is not feeling very comfortable, we need to suggest them a very different type of clothing system. Okay. Then one more thing that give you understanding of how. So based on that, I'll try to summarize this, how you gonna perform all these thermal simulation. So why thermal simulation is needed? Will give you a predictive information how, and try to quantify the whether you can keep you can also pull apart from your clothing or physiological information. You also keep the environmental condition into loading, so that your thermal simulation will be much more realistic in the sats and then in that sense. And generally for thermal simulation, people use for HVAC optimization, for seat designing, or for comfort in cabin comfort analysis. People do this thermal comfort analysis for the range calculation for AV vehicles. Suppose your AV vehicle HVAC system is using the energy of your battery, so that you need to understand when, because you want to switch on the HVAC system to make a human comfortable. If you're trying to understand how much human is getting comfortable at what temperature, so that you can optimize your range. And in this human thermal stimulation, we have to consider your environmental condition, what is your physiological condition, what type of human informatic information is there, how much, which actually what body mass index human is posing, and what is his gender, what type of activity he is doing, what is the level of his activity. So this will influence for going all these experimental, and it's not easy for a to create a chamber and do the all this situation scenario. And you suppose experimentally trying to do it, it's very tough, very tough, no one will ready to stand at minus 40 degrees situation in a chamber and holding a gun for 4 hours or 5 hours. So it's like not easy for them. So in that sense, to validate the simulation result, we may have to do some time. We kept a mannequin there. Okay, so mannequins have some few sensors around his body and try to capture that temperature, and based on the temperature calculation which is coming out to your system, and then we try to evaluate the mannequin information and try to validate the simulation result with the mannequin results. So this thermal simulation is very much needed when trying to understand the comfort and sensitivity of men for in any adverse situation. A lot of guys are doing for in cabin condition, clothing optimization, clothing design, for boot design, or it is very much needed for even for those who suppose a situation when you have a cabin and electronics heatings are going surrounding you. So we need to understand how much where you should keep your HVAC system. What will your mass flow rate, or how much the temperature is sufficient to make human comfortable. That is the situation where you need to do the thermal simulation to make human comfortable. So hope I am clear to everyone in this. If you have any question, I'll happy to answer. Yeah,
Dear,
please go ahead, sir.
dear participants, if you have queries, please you can ask to the Dr. Tabish. You can unmute yourself. Manish sir, you can ask the question.
Hello, sir. Thank you for such a nice presentation on thermal simulation.
Thank
I
you,
have
sir.
seen various cases based on the thermal simulation. So, have you verified all the result with the actual or experimental test?
That's why I told for actual validation, we do have an option to do that when we try to validate our result with generally with mannequins. Okay, and then we have some correlation already developed by different things like Berkeley model correlations or Filala Athenal correlation that will try to validate our simulation result with that correlations. That will help you. Otherwise, creating a real environmental situation for human keeping, but by keeping human in that condition, the only is not we are not keeping any experimental setup to validate the result. The only thing that we can validate when you have a human inside human in that condition, that is not experimentally almost not feasible, although based on the data available or the mannequin information we have, or based on the mannequin experimental things that we try to validate the result what we found, and it's well validated things, and we publish I think n number of papers in this human thermal commission. Now this is a new trend going on about especially automobile guys and your defense systems are mainly trusting on this when you're trying to do this thermal simulations.
Actually, in which software you are simulating these all cases?
What's up?
In which software?
I'm using two, three software, but the main software which helped me to do the simulation is your Python human extension. That is called Python human extension. This is a US based software. Okay, they developed in 2012 for this software only for human comfort. Before that, it was only for thermal simulation, but recently they have added human thermal comfort. Okay, so apart from that, we need to pull the data from CFD. For that, I'm using. Sometime I'm depending on open form sources data like SimFlow. Sometime I have to use the ANSYS Fluent to create a environmental situation there, or HVAC systems surrounding there, how the air is coming out from a particular places. So this was like couple simulation, but the main thing where we give you information about human comfort is your Python extension, human extension.
Okay, sir. Thank you.
Dear participants, if you have any queries regarding the human thermal comfort, you can ask to Dr. Tabish.
Hello. Hello.
Hello. Yes.
Wahidi sir, good afternoon.
Afternoon, sir.
It is a really a blend of nice presentation with case study,
Mm.
particularly the climate change part, making use of the solar part also.
Mm.
I wanted to know, like, what is the greenhouse effect? Like in one of the solar reflectors, I mean, in one of the automobile, hope it was case study number 7, where you have made use of the solar reflectors.
Case study number 7. Okay,
My
solar reflective glass you're talking about, right? Understood.
Yes, yes. So, sir, was result was, I mean, like acceptable, like because it is dealing with this greenhouse effect also.
It's not the case where we are dealing with the screen hot. The main intention was to understand the effect of material on the automobile and man human sitting inside. Okay, we are not the point of consideration. The agenda of that simulation was not the taking the consideration of your greenhouse gas effect. Okay, situation may be like that, but only when you have a change of material, you will come with a new material like different reflective systems and different transmitting glasses. So what will be the inside temperature of your cabin condition in cabin condition and human inside, and you have particular ACs on in a particular situation, what will be each human comfort level, what will be the sensation level, what is overall in cabin temperature. That was the primary agenda for that simulation.
Okay, okay, sir. Okay. And what about the toxicity of these materials?
What's that?
What is the toxicity levels?
It was a glass, simply is a glass. It's not something as only a glass with the different reflectance index values and reflectance values.
Fine, sir. Then in that case, I think as the greenhouse effect was related with this wavelength versus solar radiation,
Hmm.
which hope we are all are aware, like it will be trapped, heat will be trapped inside the car.
Hmm.
So in that case, is there any, I mean, possible solution to even take care of those, greenhouse effects
Yeah,
inside that?
that will be add-on. If you think this is a nice addition, actually, so
Right.
nice actually. That will be an add-on thing to the simulation. If you give them the information, the effect of greenhouse gases because of that is coming inside. So that will be obviously a better information or a add-on information to them. But
Right.
our simulation was only limited to this one, to
Material
calculate
and-
the temperature and understand the thermal simulation of human.
Hope if you incorporate that also, okay, that will hope at least it will give you, complete solution to.
Yeah, exactly. That will be great if you are we could have incorporated that also in the consideration. Next time it will be obviously I'll keep in this and you have so that we can suggest some better material to them also.
Yes, yes, sir. Rest of the presentation is quite good, sir. Thank you for that.
Thank you, sir.
Other participants, if you have any queries, please you can ask to Dr. Tabish. I think Dr. Tabish, you have given really nice session regarding the in thermal comfort, how we have to deal it. So it was really nice. Once again, I would like to thank Dr. Tabish on behalf of organizing committee of mechanical department, Maharashtra Institute of Engineering and Technology, Pune. Thank you, Tabish.
Thank you, Madhu. Thank you, the organizing committee. Thank you, especially for Northern Engineering College, that you invited us for this speaking, and all the sessions was being keep on going. It was a learning to all of us. I used to attend all the session because it was evening and quite comfortable for all of us guys to attend. It's a very informative session from day first to till, and all these guys who offer different expertise are coming down to you, and how you manage all these I don't know, but you have did a great job recently pulling all these expertise in one platform and getting involve everyone with different topics really is a great thing. It's not a easy, like it's not a cup of tea for everyone. Okay, thanks, great job, Madhu. It's really nice work being done. Thank you, Newton College, and been thankful to all the your management too. Thank you so much.
Thank you.
Thanks.
Dear participants, we have the next session at 5 p.m. So I kindly request all the participants to take a 10 minutes break. So this form will be open. We are not closing the Google link. So you just take a 10 minutes break. Then we'll come at 5 p.m. Okay. We'll start the next session at 5 p.m. with the next expert.
Thank you.